Okay, let's see. Video 126. It is Thursday. Good. Part 58. Okay, so I have like 10 more push-ups to do to get to my 120. I don't really feel like coding, but I thought I should at least try to make sure that this code doesn't crash. So, it's like we're getting an error, and it's this thing here. So 0 equals file data number of bytes. So that's kind of weird, and we got to figure out where that's coming from, right? So obviously, if we don't have any bytes for our file data, we kind of have a serious problem, don't we? So let's try to figure out what's going on here. So it looks like I'm trying to run a placeholder function, and that placeholder function is giving me a fatal error. Now, it kind of makes sense that that placeholder function would give me some type of mistake because it's not finished. However, that just doesn't seem right. That seems like, hey, shouldn't that have, I don't know, that really should have, I don't know. It definitely shouldn't have done that. Well, it's getting hot in here. Hold on. Okay. So, I don't even know where that code's coming from. So that's great. We gotta look into the lookup table. We got a lookup table somewhere. So, like, over here, we have a lookup table for this. And honestly, I'm just gonna get out of here really quick, because I don't... Okay, nothing there. You're kidding me. It's nothing. Okay, so... Hold on. Is this not where I have my lookup table? Okay, well, that would be a problem now, wouldn't it? You know... If you're gonna say, oh, do this thing, and it's not even in the lookup table... Where is it? Oh, no, a C2 is not in here. So we got, like, all these different ways to write things, but the one way that is not in here is... do we just want to put it in there? So... Right, so there's, like, a lot of ways we can... Right, so we could say it this way as well. So add... 2 more things. Let's just make everything 11, I guess, and then make some type of define to let's make a thing called number of elements, and then all these have to match, right? So this thing that's PNG, and then we can say convert to naked text, right? And then we could do a dashed version as well, PNG, convert to naked text, right? We could do that. And now we have 11 in here as well. Let's just go up through here and just keep on doing that and have 11 things for each one of them, right? So up here, this is going to be, you know, C99, convert to PNG. And then this one could be C99-C2 PNG. And then, once again, we can say number of elements. And by having this number of elements everywhere, we can kind of... oh, hello. By having this number of elements in here, we can make sure that everything has the exact same amount, right? And then we don't have to update every single entry every time. So let's call this PNG convert to C99, and then a dashed version PNG C2 C99. So I'm kind of using kind of my shortcut syntax, or kind of like how I would write shortcuts for these commands. I don't know if that's a good way to go about it, but I see that my code is probably crashing, not because so I think that my code was crashing not because, well, there's obviously a bug because typing something that's not in one of these dictionaries shouldn't crash the system, and that's what's happening right now. But instead of fixing that right now, we're just going to make more entries in here and deal with it later. Also, let's not zero index these, because if we zero index these, that kind of makes it kind of hard to see how many things are in here. So we're going to move this all over, or up, and one index these instead. Okay. Okay. Okay, I need to look for something really quick. I think it was called cat B, right? It was more on Imgur though. Hold on, I need to look for something in my shortcuts. It's amazing how you can't Google for things that you know, you thought it would be easy to find something, and then you try to look for it later, and you're like, oh, actually, no, it's not that easy to find things. It was this thing, maybe. And yes, this thing. Let's see. Let's add that to Imgur really quick. Images. Okay. Anyways, I'm gonna make a copy of that in case the other one is no good anymore. Cat B. B cat. Anyways, where was I? So we got this number of elements macro, and we're just going to use that to fill out all this stuff. And then looks to me that we also have these arrays here also have 11 elements in them. So we need to make sure that well, that's fine. So we're going to need some more room. So let's define EC as extern char, right? Extern const char. Right? EC. And then we can do this like EC whatever the heck. Or not. Yeah, so we could call this extern const char. Or do you want to say ECC like that? I don't know, it doesn't really matter. Sure, ECC for extern const char. And then over here, we're going to say number of elements, right? So define no. And that'll be 11, right? Number of elements is 11. And then everywhere here, instead of this, we're just going to say no. No, right? So we're doing a little bit of refactoring. And after we refactor that, let's just put a little checksum over here. And we're just going to do enough work right now to get the code running to the point where we can start writing the algorithm that we want to write, right? So we're not going to... I don't want to go for really long. It's just... I don't feel like doing anything, but I should at least get a little bit done. That's kind of the thing that's going on here. So, let's close this Chrome tab and close this. Okay, so that looks better. I am concerned that this is coming from somewhere else, though. Like, I don't know. Like, if I try to compile this, I feel like, is that going to really compile? Is that all I need to do? So, invalid command num element. So somewhere we've missed one of our number of elements variables when we were trying to replace things. Yeah, this has to be no now, right? So this is probably the only one, or hopefully the only one. And no, we royally screwed this up. So, or maybe we weren't paying attention. I don't know. So let's replace this, replace that, right? And obviously these entries are kind of not going to do anything. They're just there to kind of like seed our copyrights into the engine source code so that we can tell when someone's using our engine by looking for these strings in the code, right? So the idea is to have, like, not just do this in one place, but to do stuff like this in many different places so that we can not just make it hard, make it difficult to remove traces of, like, so I don't want somebody to strip out the copyright and then claim that they're not using my source code. So I'm putting references to it in many places, if that makes sense. Okay, so anyways, let's give that another shot at compilation. Okay, so it tried to run without any arguments, says, hey, 0 args, 1, 2, or 3, cool. And then we're going to do ./PHEXDUM.exe, and then we're going to do, we want to do naked text, convert to PNG, and then I don't know what the output file is, right? We'll just say, well, we want an input file. We're going to need an input file regardless, so let's supply an input file because we need 2 or 3 arguments. And the input file name should be PNG or TXT, and that is a horrible name that I don't feel like typing right now, but let's just do PNG or TXT. So PNG or TXT.123, right? That's just a pain. So it's still failing. I think that the loop... Hold on, I gotta take a quick break here. Okay, I'm back. I'm gonna just get back to it. I don't think anyone's watching. Okay, so let's close this. We have a problem, and that's that we're probably not going through that entire array of data, right? Like, we just added some more stuff on here, but how the heck did it know how much to iterate through? And my guess is that we hard-coded a 9 somewhere in this code over here. So if we go Control F and we look for a 9, we're probably going to find 9s in many places. But, yeah, so like right here, here's our synonyms. And we can see the max synonyms here is there's 9 there, and it's hard-coded in there. So what I want to do is, well, first of all, I want to do no plus 1, and you're going to see why for a second. But let's highlight this and say, hey, yeah, everyone's getting a plus 1 for a second. And it's like, you might be questioning why I'm adding a plus 1 to everything, but you'll see. Okay, so no is for number of elements, and we're going to add a plus 1 to that, to every one of them, so that the last element, we can just say, hey, you're going to be CHR pointer 0. I'm actually going to explicitly give, so this is a, so 0, 1, 2, 6. Right, so we're just making a null terminated list here, right? So that's all we're doing there is making a null terminated list. And we're going to do that to every single one of these lists. We're going to say, hey, you are now null terminated. Your last element is actually this. But as far as iterating over this, it doesn't know about, when we iterate through the loop over here, it's not going to know about that null terminator because we do no plus 1, right? Number of elements plus 1. And what we can do next over here is when we're looping through this table of synonyms, right? So we're going to compare the command name to the table of synonyms. You know, if do we have a char const char? Yeah. So if CHR pointer 0 equals table of synonyms syn air should so we're going to make a little error message here, and it's going to be sub. Sub is going to be for should exit, and then HIOL will be before oh, Gaia. That's what I did. So, how about this? Oh no. How about, you know what? Just screw this. Let's just say 2021 0204 0801 p.m., right? Just we'll make the error the actual date, right? Just and yeah, we'll just make the error the actual date. And we'll put a note here that says, you know, should exit before without ever hitting the null terminator, right? So now, is that how we want to do it, or do we just want to like keep looping forever? Do we want like a while loop, right? Do we want a while loop? No, because if we, the null terminator is just an extra protection, I think. So that we can crash rather than segfault, and I think that's okay. So now, this number of elements here, we actually should use some type of define for that, right? We should have a define or a variable or something up here. Actually, it needs to be a const expression if we're going to put it in an array like that. So in misc whatever, which seems to be getting kind of big, but I just don't care about it right now. We're just going to say, we're just going to put another variable up here and say, AAC 2020 PHEXDUM synonym max, right? And this will be a define. And synonym max will be, there's 11, right? Max index of max number of synonym. Let's call it syn no for number of elements. And then what we can do is where we have that 11 hard-coded, this 11 hard-coded, we're just going to say that it equals this thing here, right? And then we can go over here and we can also define no as this, right? So that we can get rid of this hard-coded 9, right? So we can say, are we the command we want? And then right down here we can undef no for number of elements, right? Number of elements. And then we can just say number of elements minus 1, right? So we're going to go through number of elements minus 1 to loop through everything. So now if we do this, I'm hoping that the command that I've been trying to type here will actually get me somewhere. If we did that correctly. So it looks like that compiled. So the next question is, will this command actually do something besides what it did before? So we're better here. So now it says, you know, AAC 2020 PHEXDUM finish this algorithm logic, right? Which is actually what we want to do. Now, the thing we need to fix, though, however, is it seems that when we type gibberish, right? When we type gibberish, it crashes, right? So fatal error, it's like, so I don't know what's up with that. So it seems that the number of bytes is 0, right? And that actually kind of makes sense, but kind of doesn't, does it? We need to figure out what's up with that. There should be no payload if no command gets executed, and I don't think any command got executed, except the default function got executed, right? So if we're in here, so the, hold on. So the default function probably got executed, right? The the default, like, if, like, we have all these conversion functions, but there is a function that's supposed to get executed when there's an invalid command. And I'm not sure if, well, actually, no. I'm not actually sure what happened. But we gotta figure out what's going on. And, hold on. So yeah, we have to figure out what's going on. I don't know what's going on, but we gotta figure out why this is happening. Before we work on the logic of this thing that needs to be finished, it'd be nice to find out why this is going wrong. And we know that what's happening is somewhere it's not finding the synonym, right? It's going through all the synonyms, and it's like, oh, nope, we don't know. We don't know what that is, right? And if it doesn't know what it is, then what the heck is it doing, right? Like, what is it doing if... Right, so it says command enumeration, right? Right, if it's selected, then the command enumeration gets set, right? Otherwise, so we got this void function, integer pointer, command enumeration. Do you want to get the... Are we getting the, So this is telling me... Am I trying to... And I didn't even label this. It's like, what the hell? Void function. So this is any function. Oh, got ya. So first of all, I need to label this. Return enum. Alright, so we are literally returning an enumeration or a function pointer. We're returning one or the other. And I guess we could put the return within the section. And the idea was this was written kind of generically so that we could do this, where we could say, you know, void, this is the void function, right? Void function pointer. This is the return data. And the reason this is a void function pointer is because a void pointer wouldn't work because we can't take a data pointer. We can't take a function pointer and cast it to a data pointer, but we can take an integer and cast it to a function pointer without getting ourselves in trouble. So we can make a note of that. Alright, that's the confusing point. Void function pointer here is being used like a void pointer to return either a function or an integer value. We use a void function pointer instead of a void data pointer because compiler doesn't like it when you cast a function pointer to a Alright, so this is so it's a little bit confusing because this pointer right here is basically this is used as void pointer, right? So this is used as a void pointer, or okay. So video 126 and at 31 minutes 50 seconds right here. So yeah, so this logic here is just trying to return. The return data can either be a function pointer or it can be an integer, and we can't use a typical void pointer for this because the code just won't work, right? So so we need to shorten this though. So command enum or cmdfunc, right? And I get why I named it that way because it's either this string or this string, right? So that was the reason for doing that. However, this makes it a little bit complicated, right? Because this is a little too. Can we just say string compare? Can we just do that and just call it a day? I think we can. So let's just go here and say, define sc strcmp. Then over here we'll go undef sc, right? And let's see where sc also is in the code. Is it only in this section here, or is it in somewhere else? Nope, it's just here. That's cool. Okay. It's nice when it's in less places. So, okay, so we know that we want either a data or a function. And what data or what function do we get when the synonym isn't recognized, right? So we loop through all these synonyms, and to me it kind of looks like if 0 equals whatever the heck, it looks to me that you could end up... Is the command function ever set to some type of default up here? Nothing found. So it's set to this command, nothing found. Okay, so that's a step in the right direction. So the next question is, well, what does that function do? And does it make our life hard on us, right? So so we see this is called anyText, and it's set to this string that says command not found. Great. Okay, and the string length is, we're taking the payload error in the anyText string, which is set right here, and we're setting it. So that looks good to me, where it's like, that looks good. I mean, that's what I was expecting. However, we're still having a problem where we're not seeing this message. We're not seeing command not found. We're seeing absolutely nothing. So I don't know what's going on here. So first thing is, let's just do a little print here. I don't really want to get out of here, but let's do a printf. Okay, so we're going to delete this later. This little debug message, but I just want to see if that actually ever gets called. Like, is this function getting called, and it's the problem the function's getting called, and the array length and the anyText is just like not working, or what's the problem? I don't know, and I don't want to do this. So let's just say blah blah blah, right? So blah blah blah, nothing found, delete me, fatal error. Okay, right? So we're getting to this part, and then it's just saying that this number of bytes is nothing, right? And the thing is that kind of makes sense. Number of bytes would be nothing. Now is strlen reporting something that shouldn't be? Let's Let's check our outputs. I don't think that strlen would be doing anything, like in terms of returning 0. But it seems to me that it could be. So, you know, so I don't think that's what's happening, but we might as well check, because this would happen if that were the case, but I don't know why that would happen, because we don't have anything in there that would do that to us. But let's compile this and see if maybe that gives us some information. Bad array length. So actually, yeah, so that's weird. I don't know why that's the case. But let's think about it. So this dot array length, we do str length of this, right? So I don't know why that would happen, because any text, we put it right in here, right? We put it right in here, and we said, yeah, create a freeable string, right? And for whatever reason, create freeable string is like, oh, screw you. So now the next question is this any text? Is it null, right? Like, what's... Hey, how's it going? So I'm working on taking the hex dump and yeah. Yeah, so I'm just trying to get this basic stuff done. I don't know what I did wrong. But yeah, I'm just trying to... I was working on a utility to do some hex dumping, right? Take a PNG file, turn it into hex dump, and then be able to like embed that hex dump into my source code, so that I could like have a way where I could create a pipeline to embed assets into my source code, right? So to embed the assets into the actual game engine, you know, take a PNG file, convert it into a binary hex dump, and then take that array of hex values and just shove it into an array declaration somewhere in the source code. I don't know if I already described this to you. I've described it to some people. I don't know if I've described it to you. But it would be like, let's say we do the hex dump, right? And we get something like, you know, we get a hex dump, and the hex dump is going to be in a format kind of like this. And then what we'll do is in some file, in some source code, we'll be like, you know, U32 my data, right? And then some number here. And then right here we go include that hex dump.txt, right? So we'll do this something like this. So this right here would be that hex dump.txt, and then somewhere in source code we would do something like this, where we have like an array, and inside the initializer we just use an include statement to shove this hex dump in there, and that can be a way to get a pipeline going. And so I have a pipeline for like embedding assets into the game. So I got this working. But now I want to do the inverse. I want to make a full tool for this. Like I want to do the opposite conversion, where I take a hex dump and put it back into a file. And it's just I want to write it for completeness. And it might not be the best use of my time, where it's like, but I don't know, I don't like leaving a tool half finished, where it's like, I know I only need this one feature of this hex dumping tool, but I would like to just make a complete tool. So if I'm going to take something, if I'm going to take binary and convert it into a serialized hex dump, then I want to also be able to deserialize this kind of text and turn it back into a file. So right now I'm trying to figure out why So for whatever reason, it thinks that this array right here, that the array length is less than or equal to 0, but I did a string length right here. So I did string length on this right here, and this anyText has been assigned right here to this string right here, but the string has been wrapped by this macro that I made called CFS, which means create freeable string. So if we look at what CFS stands for, I don't know why it's going wrong here. But yeah, so this create freeable string function right here. So we take a pointer to a non-freeable string, and we just basically copy it, right? We copy it and calloc it, and then we also make sure to make absolutely sure that there's a null pointer at the end. So we do strlen, which I believe does not include the null pointer. So we got to do a +1, and we calloc that. And then we make absolutely sure, even though we already calloced, we're going to make absolutely sure and put a null terminator there at the end. And that seems all right. That has seemed to work for us in the past, so I don't think that is the problem. I don't think that's the problem. So I don't know what I'm doing. I think I'm going to I think I'm just going to, well, first of all, we got to figure out why this array length is bad. And we have this string here, so my next question is, if we just do strlen, so if, so is the core problem that somehow, the string that we used is not, reporting back as having a non-zero length? Like, I don't know why that would be, but, I have no clue why that would do anything. But right now I am kind of like very confused. So it could be this. Let's take this as well, right? So let's so this is the wrapped version of it. And we're just going to keep on throwing some things into here until something sticks. So we'll build that. Hopefully that will build. Hopefully we won't make any mistakes. And str length, no find. Error, no find undeclared, huh? Did I type that wrong? Oh, no. That's not the problem. It's just that if we really want to use if we want to use that macro in the checks, then we're gonna have to use it further. We're gonna have to declare it further up, and I mean, I guess we can do that. Even though it's gonna look kind of messy, but we could do that. So we could put it up here, and then we could go undef no find, right? So, alright, so we could put it up here and see if that helps us. Error, no find undeclared. Because we also have to delete it from here if that's what we want to do. So we have to. Okay. Let's give that a shot and see what we can do here. So okay, and now if we give it so it's compiling, but the question is, how about that gibberish? If we give it that gibberish argument like that, what's going to happen here? Bad anyText length. So this thing is not working. Now, are we getting a void pointer? A void pointer. I don't know why this would be reporting. I don't know. Let's try to add some more indirection here. So let's do oh, hey, sorry. What language is this? This is C11. C11 looks oh wait, C. Oops. Oh god, I can't type here. Yeah, it is C11. You are correct. Though I do use like a lot of macros. Have you been here before? Because I can give you a quick. Yeah, I can give you a quick tech demo of what I'm working towards. But you are correct. This is C, but I kind of write my C in kind of a batshit crazy way. Special is a nice way to put it. But yeah, so the reason why my formatting is kind of very weird is because I have a 64 columns. Yeah, 64 columns is really hard limit to keep unless you take some very extreme measures. And so there's a few things I do. For example, right, I like to know the domain of a comment or the jurisdiction of a comment. So, right, left justified is the start of a comment, and then right justified is the end of a comment. Yeah, 80 is also a good limit. Like, everybody's getting, like, monitors that are, like, I was, like, doing this, I did this interview at this one company, and they had these really large, high-def monitors, and all their code was, like, over 120, and I'm like, it made me want to puke. But yeah, 80 is a good limit. I like 64 because it's a power of 2, and I use 4 spaces for one tab, so everything goes into it evenly, but then 80 as well, because 80 and 4, right? Also divisible. But yeah, I give no, with max 80 or so, I can fit 2 documents side by side without scrolling sideways. Yeah, that's kind of, yeah, so you're right on. That right there, that is exactly the point. Because, like, right here, I have, like, one document right here, and I have another document over here. Yep, exactly, yeah. Like, if you, and so the other thing is sometimes I need a little bit of extra space here to, you know, grab things. So it's nice to have, I use a mouse, right? I'm not, like, using, like, Emacs or Vim or something. So, like, sometimes, like, if to work my way around the code, I need a little bit of extra space over on this edge. And so if I did 80, I mean, if I did 80, I don't know if it would be, I don't know, I need enough, it needs to be so much condensed that I can have, like, the text nice and big on screen while I'm working on it. Because I'm trying to use the videos to kind of document the code progress. So, like, if you see in the codes in some places, like right here, like you see this comment here, that actually, yeah, font size matters, yeah. So this comment right here, this stands for video ID 125, and actually, was that yesterday? Hold on. Yeah, that was yesterday. But you can see in the bottom right-hand corner of the stream, like if I throw this in here, it's going to be kind of weird. But you see the bottom right? The video ID is 126. The day is Thursday. The subsystem I'm working on is called PAINT5D, and the project is AAC 2020, which stands for Atomic Alice C Code, year 2020, meaning established in 2020. And then PHEXDUM stands for PNG hex dumper. That's the specific thing I'm working on. So you could say the project, the sub-project, and then a very specific sub-project. I don't know. Like, there's a whole bunch of little tasks that I'm keeping track of on the bottom of the video. So when I come back to these videos or see something in comments, like, I can tie the videos to the code, if that makes sense. So what does your username stand for? Is that like my STRAN or like, or yeah. So I was just trying to get a little bit of work done before flipping my table. Mistran? Okay, Mistran? Like the game Myst? Is that how you spell the game Myst? Like, what was that one game? Isn't it called Myst? Like, MYST? Yeah. It was, this puzzle game from, when was this puzzle game made? Like, I think this was like a 90s game. Was it a 90s game? Okay, I got ya. But yeah, right now I'm trying to figure out, I don't know what's going on with my code, honestly. Like, I have a string, well, I'll show you. So, hold on. So this string right here, this hard-coded string here, the string length, well, actually, hold on. So, if you have a hard-coded string in your code, you can't free it, right? Like, but it's originally a completely random name I came up for a pen and paper RPG character. Okay, I got ya. Yeah, so, a string, if it's hard-coded into your source, it would be a bad idea to free it. So that would, I don't know what would happen, but I'm pretty sure something bad would happen. And I just didn't have any better nickname to use at the time, and it stuck. Oh, I got ya. Yeah, like and it's reasonably unique on the interweb, so yeah, that's always a good thing, because you, like, sometimes when you have your username taken on other sites, and it's kind of hard, like, a lot of times I'll use this one, yeah, I use something like that sometimes when I want something completely unique, but I know how that can be. Anyway, so if you have a string that's hard-coded in your source and you try to free it, you're going to end up with trouble. And we have this payload object. This is specifically called payload air. So I actually keep a big dictionary of all my variable names, so you might look at this and be like, oh, that's incredibly terse, and it is true, it is incredibly terse, and all my variable names are either 1, 3, or 7 letters long, sometimes longer, but usually it's 1, 3, or 7, and variables that are putting at the very maximum allowed limit is, oh yeah, like, well, I figure, I figure if I have a tight column limit, then oh. Yeah, so the idea there, where it's like putting everything at the exact limit, that is to make absolutely sure that if somebody else opens this source code in GitHub, right, if someone looks at this source code in GitHub, they're not going to have this column limit here, right? So the idea there is that if somebody looks at this code, so let's go to GitHub really quick, right? So let's do that for a second. So go to github.com, right? So if someone goes into GitHub, it's going to be very obvious what my column limit is because I've been so meticulous about it, right? It's not going to be like, I mean, we could look at this, like the README is just basically a big piece of code where I put in different sections here, but you can see that it kind of implies that column limit, right? So when you're looking at stuff, you can be like, I think this person uses a certain column, right? Or like, you know, if you go into any of the library code, right? So here's the library code right here. And we go into any one of these things, except some of them are a complete mess, but some of them, like the newer ones that I've been working on, are a little bit better. So here's like some unit test code for the GLSL shader code. And you might be thinking to yourself, well, GLSL shader code can't have tests because you can't test shader code. Well, not my shader code, because I wrote my shader code in a very generic C99 style, and then I used some pre-processing to compile it as GLSL. So I run unit tests on it on the CPU side when I compile it as C99, and then once it passes all of its tests on the C99 side, I can be confident to run it as GLSL code. And so there's so this shader code here, if we look at it, there are a heck of a lot of defines, right? So you can see this one's called like when running as GLSL code, right? So U32 is uint, I32 is int, IVEC2 is IVEC2, UVEC4, UVEC4. And then if we are running it as C99 code, then right, U32 is going to be a uint32 type, I32 uint32 type. Then we need some polyfills. So for TF, for texel fetch, we got to create a polyfill for that samples from a bitmap that's on the CPU side, or sometimes they'll say like the host and device side. I don't know what the best terminology is, but I kind of steal host and device from like OpenCL. Right, and then IVEC2 and UVEC4, they don't exist, so I have to create my own struct. So this polyOGL stands for polyfills OpenGL. So my namespacing is double namespaced everywhere. So the main project namespace is AAC 2020, and then the different subsystems get a namespace as well. So I have this like ridiculous, calling them CPU and GPU is probably the clearest. All right, yeah. Yeah, I'll keep that in mind. But yeah, because I figure host and device sounds very academic. Yeah, you know, when you say that, OpenCL probably has a lot of so OpenCL probably has like a lot of people like doing very sciencey kind of things, and that's probably why they say host and device. Though I think they also do that maybe to abstract it, because when they say device, that really is GPU, but they're saying that, well, it's not necessarily they're being more abstract than is necessary. Well, no, for their architecture, for their library, I guess they're not being more abstract than they need to be. But they're saying device because it might be something besides a GPU in the future. But I actually don't like to write my code in so in theory, device could also be the CPU if there's no GPU. Yeah, I mean, yeah. Exactly, right? Or, right, or different multiple cores or something, yeah. I actually like to keep my code... Yeah, exactly, yeah. So, yeah, definitely the GPU, yeah. Yeah, originally I wanted to use OpenCL, but when I did OpenCL GL interop, I got horrible performance because my graphics card, my NVIDIA graphics card, does not do a zero copy share as it's supposed to. So the memory, when it has to bounce back between OpenCL and OpenGL, it has to copy all of the memory from OpenCL, bring it down the PCI Express from the GPU to the CPU, then upload it back up the PCI Express from the CPU to the GPU, and it has to bounce back and forth like so. It has to copy a whole bunch of memory and then pass it and do like a round trip just to pass it from one thing to other, when the way OpenCL interop is supposed to work is it's just supposed to share like one piece of memory. Yeah, it's a bug. It's a bug in my driver. But I was reading about OpenCL because I'm trying to figure out if like OpenCL is safe enough to go with, and then that happens to me, and I'm like, okay, yeah, I probably could update my graphics card or whatnot, but that seems like kind of a bad omen because I'm like, I worked on a game for like 2 years. Here, let me show you. So I don't know if you've seen this before, so I'm just gonna pop open my technical demos. I can send you. It's pretty old. It's a 3-year-old graphics card. It's a GTX 960, I think. But let's go over here for a second. So, I don't know. I think it might be able to do compute shaders. Because I do want to, the algorithms. Oh, damn, okay. Yeah, the algorithms that I'm working with would make more sense in, like, OpenCL, so I am wondering if I could get better performance by figuring out how to convert what I've been writing into a compute shader. But right now, it's just about getting something working first, right? Get something working first, and then worry about how to optimize that later. But yeah, so, like, in around 2012, I was working on a game. This is a little screenshot of the game. I have some more screenshots, but it was done in Flash, and it was like a Bomberman game. So like the bombs could have different explosion directions, so like horizontal, vertical, 4-way. The bombs were also proximity mines, so if you touch them, they don't immediately explode. They like blink for a little bit, and then they explode. And they can take out pieces of the world. And certain pieces of the world have physics on them and will fall if like they don't have any support from underneath them, right? So this is me just destroying a little bridge. The little buttons emit sparks, and when the sparks hit bombs, the bombs immediately explode. Anyways, so after getting burned by using Flash, I decided that I wanted to create like a new engine specifically for this kind of game. And I kind of have an obsession with auto-tiling. So I made some little proof of concepts. So here's like doing auto-tiling with shader code, right? So we have different shaders that we use to create auto-tiling textures, right? And we can zoom into them, right? We can zoom in, say, 256 by 256 for each tile, right? And when you zoom in, you still have that nice, beautiful, like, detail, right? Unlike with the pixel game, where if you're doing auto-tiling graphics with using pixels, you can't like zoom in like at this kind of crazy level, right? So I'm trying to incorporate a lot of these prototypes on my demos page into a final engine design. So right here, I wrote this in Flash as well. This thing you're seeing here, this is a tile map I wrote, a tile map rendering engine. So the tile map has different layers, and then you can blend together the layers and then apply different rendering settings. So this is 3 different rendering settings applied to the same tile map. So this one's called Foggy Morning, this one is Sunset, and this one's Starry Nights. They're all the same rendering setting, but they are all... Sorry, did I say same rendering setting? Sorry. Same tile map, different rendering settings. So the idea is to get a lot of data leverage. I don't know if that's a real word, but that's the word I've been using. And when I mean data leverage, I mean the artist creates this one data set, right? Because a tile map is basically just a data set, right? The artist creates this one data set, and then we can render it in many different ways. So we get like 3 awesome pieces of art for the price of 1, right? So that's what I would call data leverage. I don't know if that's a word, but that's what I'm calling it. Until someone gives me a better word. Yeah, so I'm thinking about, well, so here's the lighting engine I worked on in the Flash game, kind of overblown to kind of show it off. Here's like the little preloader screen I made for the game. Here's a little proof of concept, like tile set editor that I was working on for making auto tiles that have 16 subtiles. So this would be a Wang style auto tile, right? So there's in I think one of the GPU gem papers, there's a thing about Wang tiles. I think there might be some term for that concept, but I can't for the life of me remember what that would be. Not right now, anyway. Yeah. Yeah. Well, I mean, if you figure it out, yeah, if you figure it out, let me know, because I have no clue. I have no clue what to call it, so I just call it that. This will not go into the engine I'm working on because it's based on triangles, but it's like a little snowflake maker. Now, it might actually look like I am copying pixels and rotating them and pasting them. That is actually not what's happening here. There's actually 6 different systems here that are rotated, radially. And then the messages that I'm using, when I click, it sends a message into a certain system, and then it propagates it into the other subsystems. So, like, right here, like, when I click up here, the reason it's duplicating is not because it's copying, pasting pixels, it's actually just taking the message. It's taking the message from this click, and then rotating that message and putting it over here, and then rotating the same message, putting it over here. So it's like, it's broadcasting my clicks to these mirrored locations, right? So there's actually, there's these big triangles here, right? There's 1, 2, 3, 1, 2, 3, 4, 5, 6. There's 6 big triangles, right, that create this hexagon, and each triangle is one system that I wrote in, like, JavaScript with Canvas. And this is a quad tree, right? It's a quad tree. And, you know, you can dive deeper and deeper into it, and the colors just randomly alternate. And it's kind of cool because if you click drag, you can just get this, like, craziness, like, ooh, right? That's kind of fun, right? So this won't be in the engine design just because this engine is for fractal auto tiling, and my tiles are based on a square grid, not triangles. But this is still kind of a fun thing to mess with, you know? So also I use shortcuts like crazy. So like I have over 30,000 shortcuts in a big script. So, you know, I type something, I type some type of phrase, my shortcut script keeps a rolling window of all the keys I've been pressing. And once I press 2 commas, it checks to see if I've typed anything that is a valid shortcut. Also, my shortcuts always look for the largest match. So if you type pizza or pizza pie, if those were both shortcuts, pizza and pizza pie, then if you type pizza pie, you'll get the shortcut for pizza pie. You won't get the shortcut for pizza. Or I guess I have to explain more about how my shortcuts work, but basically, right, it always takes the longest match it can find. So that's some other stuff I've worked on. I did this thing in Unreal. I think this is really cool, taking shader code and putting it into Unreal. I really like how Unreal takes, when you have shader code and the colors go outside of the normalized range, they begin to emit light, right? So I think that's really cool about Unreal shaders, right? So, yeah, because this won't render like this in other engines. Only in Unreal Engine will it make that kind of light emitting. I think that's really awesome. I don't know how they did that, but I think that's awesome. Made this little fireworks system in Unreal. I don't know, I did a whole bunch of stuff in Unreal because I was trying to get a job working at a certain game company. So, anyways, I'm gonna try to figure this out. I have no clue why. I think I'm just gonna say, yeah, bloom. Yeah, bloom, I guess, would be the bloom on overbright. Yeah, overbright, yeah. I guess overbright would be the term. I don't know all the terminology for graphics programming. Oh, right, sounds right, yeah. So, anything outside the 0.0 to 0.0 range yeah, yeah, anything outside that range. I don't know what happens when it goes negative. I don't know if it does any like weird, like anti-light. I don't know what happens when it goes the other way. But yeah, when it goes outside that range, it starts to emit light. So I think overbright would probably be the word. I've heard of like something called like HDR, but actually I think HDR is just 64 bits for your color values rather than 32. I think that's how. Yeah, HDR, high dynamic range. So that's not the same thing as overbright. But there's a lot of things about graphics programming I don't know. And that's kind of why after doing 2 Hello Worlds in Vulkan and getting a swap chain, I kind of gave up on Vulkan because I'm like, I don't know enough about graphics yet for learning Vulkan to be useful to me, right? Like, if that makes sense. Like, I feel like once I get good enough at graphics, once I get to the point where I need the things Vulkan has to offer, then I'll be ready to learn Vulkan, if that makes sense. Right, so basically you render into a HDR, e.g. floating point render target, then you run blur on that, then you basically add the blur on top of the original, so it's only visible on brightest parts, and then you tone map, which is a glorified soft clip, basically. Let's see, so I read a little bit on how people do blur with like post-processing, where they can do like what do? They do like a blur on the X and then a blur on the Y, which saves a whole bunch of time rather than doing like a two-pass blur where they blur on the X-axis first, then they blur on the Y-axis, and somehow doing that in 2 passes reduces the amount of work by taking like the square of however much work there would have been. But I don't know what tone map is in soft clip because I'm not really I'm not very what do you call it? I'm not a professional graphics programmer. I'm just a person who tries to make things that I want to make. But I should probably read more GPU gem papers because I think they have a lot of it's hard to, what do you call it? It's hard to learn about this stuff sometimes, I think. It's not like it's not, I don't know, maybe I could be wrong, but it's not as easy as like just picking up a C book and reading about it and then, oh, I know about it. It's like the information seems scattered all over the place. HDR just means more than 8 bits. Okay. 8 bits or RGB? 8 bits. 8 bits per pixel? Yeah, or no, 8 bits per channel, right? So RGBA, 8 bits is a byte, so 8 bits per channel. It's also possible to do a similar effect without HDR if you only render the brightest parts and blur that. I'm pretty sure Unreal these days does the real thing. Could be wrong. Oh, soft clipping. It's not really a graphics term, but the idea is that when values get large, you don't just clip them to 1, but rather use a smooth curve. Okay, got ya. Yeah, more than 8 bits per channel. Okay, got ya. Yeah, so so I guess I should probably give you a review of like what the hell is going on here then. So I am making a hex dumping utility, and I know in retrospect, I probably could have just used XXD for this, but I'm already writing it, so I'm just gonna finish it. Because I don't know. I mean, I'm writing my own tooling, so there is a benefit to having your own tools that you can use however you want to. But so I take a PNG file and then I turn it into a hex dump like this, right? And this hex dump goes into a file, and then later in my source code I can include that hex dump into an array of data, right? And then the utility also has to be able to correctly interpret this as a byte array, right? So I have to worry about endianness. So I need, and the reason why I'm gonna do it as, 32-bit integers rather than a byte array is because the hex dump takes up less room, right? Like, I want to minimize the size of the compiled executable, but I would also like to minimize the size of the source code if I can, right? So, like this takes up less room than something like this, right? Like, the equivalent when using bytes would be something like, like this, right? And so the same amount of information, right? This and this is the same amount of information, but one is much more compact than the other. So in order to save space in the actual source code, I'm going to use uint32 arrays to encode byte arrays. Tell me about own tools. When I write my code in a text editor, I wrote from scratch. Oh, that's pretty badass. That's pretty cool. Yeah. I always thought it would be cool, like, so there's all those ideas that you want to do, and then you have to just write them down in a big, like, list of things that you'll never do. I always thought it would be nice to have, like, a, I call it the serial killer editor. You know how, or when people have, like, in those movies where when people have, like, schemes or they're trying to plot something, they get big board, right? And they put out, like, they take a whole bunch of newspaper clippings and they put it on a wall or something, and then they connect, like, lines between different things. I thought it would be really cool to make a text editor where you could connect lines between all of the variables where the data is flowing, right? So, like, if we did something like, var, let's not do JavaScript. Int a, right, equals 100, and then int b, int c, and then int d. And then, let's say, like, over here we do, like, b equals a, and then over here we have, like, c equals b, and then over here we have d equals c. And it would be cool to make an editor where you could, I'm not telling you to do this, this is something that I eventually would like to do, but it's like, too many projects. You gotta pick one thing and stick with it. But it'd be cool to make something where you connect a line between this B and this B, and then you also connect, like, a line maybe between this B and this C, and then connect a line between this C and this C, and then connect a line between this C and this D, so you can actually see the flow, right? Because when I think a lot of programming is just connecting the dots. It's like, how does this one thing get to something else, right? And so to have an editor where you could do that, and also an editor where you could have, like, two windows side by side and have this kind of thing happen where you could have lines connecting different variables that are related. I'm really bad at pick one project, as I always have a dozen. Yeah, I totally get that. I totally get that. Yeah, I've scrapped more projects than I can count because of that, right? Because it's like, so right now I've had this rendering engine idea for about 8 years, and I've done little prototypes here and there, and it's taken me, it's crazy to say it's taking me 8 years, but it's taking me 8 years to find a language that I wanted to use after ActionScript. So I messed with, like, hacks. And what else did I mess with? I messed with hacks, obviously JavaScript. I messed with WebGL, OpenGL, SFML, Golang. I know Python, a little bit of Python, but I never considered that for a game. I know Java, also never considered that for a game. I hate Java. Python is useful, but I don't like the spaces matter kind of thing that Python got's going on. But yeah, it took me forever to figure out a new tech stack, and I wrote a sizable amount of code in JavaScript and Golang before I decided on C. And the reason for that is I've made multiple prototypes in JavaScript, but then I always get screwed over on I/O, where it's like, oh, you want a full game? Well, I guess you're going to have to make a web server because file access permissions And then the final straw for ditching the JavaScript code base was PNG compression and decompression. And doing that by taking a payload from across the network and not getting it corrupted before you try to uncompress it. Like, good luck. So I was like, you know what, screw this. I don't want to make a toy engine, so let's not do it in JavaScript. Let's do it in something serious. But I was kind of scared of doing things in C, because I'm like, C is kind of like a serious language for you know, people who are actually programmers. And I guess I'm actually a programmer. I mean, I've been programming since high school, so that's like, I'm like 35 now, so I've been programming for a while. I guess I can be an actual programmer now. But I did Go, and I liked Go. Go is pretty cool. But then I read that Go was basically a modern C, and then I'm like, you know what, I hate garbage collectors. And I like Go, but I hate this garbage collector thing. Oh wait, Go is just a modern C? So you're telling me that I can get something like Go, but it's better than Go because it doesn't have a garbage collector? Oh, sign me up. Oh wait, that's C? I thought C was just this archaic thing that nobody did. And I'm like, oh wait, C is actually exactly what I want. Because every time I try to code something, I always inevitably, yeah, exactly. Every time I'm coding something, I always inevitably get burned by, I'm trying to do something too complicated. Something too complicated that can't be done by a language that is not, like, a serious language, if that makes sense. Because they love to start collecting garbage when you'd rather be rendering a frame. Yeah, exactly, yeah. So in Flash, when you're programming in Flash, one of the ways to get around that is you just pool all your memory. Which I think can be a pretty good strategy even in C code. If you know that memory is always going to be around for the start and end of the game, then allocating a file scope array of all that memory, I think, is a pretty good way to go. As long as you know that that memory is going to be needed from the start to the end, right? Like, I think that that memory pooling is still a good thing even if you don't have a garbage collector, because it can help you avoid... The less mallocs and free you do, the better off you are, I think, in terms of avoiding shooting yourself in the foot. Or at least I find that I can never malloc. I could never malloc and free. I mean, it seems easy. Oh, just malloc the correct number of bytes, then, you know, free it later when you're done with it. But I always get something wrong when I am doing that. So the more things I can statically allocate, the better. Or I guess file scope allocate. Right, I've been programming from the age of 7. I've mostly been programming C and C++, and the older I get, the less I allocate stuff dynamically. Yeah. So it's like, you just, you gotta know, yeah, you don't allocate it dynamically unless you absolutely kind of need it to be allocated dynamically. For instance, in this program, because it's a hex dump of arbitrary data, I allocate the memory that's going to be saved to file, and then once I save it off to file, I free it. But I'm still finding myself with problems doing that. For example, because this code... these days I mostly write C++, where you have std vector as a dynamic array that you can resize, but even then you tend to resize or reserve it to the size you need, and that's it. Yeah, I got it. Yeah. Anyways, let's try to figure out what's going on here. So, have you looked at C++? So I did actually do a little bit of C++. Yeah, I have a tendency to over-engineer, and I kind of think C++ would be dangerous for me. You know, I do... like when I was coding, you know, I was doing, you know, action scripts, so I am familiar with, like, you know, inheritance and polymorphism and whatnot, and like derived classes and base classes, or also known as what do you call it? Subclasses and superclasses. I always have to remember that subclass and superclass always get me confused, because I always have the wrong diagram in my head, because it's what is it? Super is on the top and then sub is on the bottom, right? Because it's like a pyramid. Like, if you, the way you diagram it out makes a. So I have the same problem with trees, people when they draw trees. I didn't know you were supposed to draw trees from the top of the piece of paper downward, and I always drew, when I was trying to figure out code, I always draw my trees from the bottom of the paper and upward, and I'd always get confused. And then once I realized that people had their diagrams flipped around when they were, yeah, you have to know what mental diagram people are using when they're talking about things, otherwise you get really confused. But I like base class and derived class, because subclass and superclass I can never remember which one's which. But base and derived makes sense to me. But sub and super, I always confuse me. The thing about C++, though, is that you don't really need to go crazy with object-oriented. Yeah, yeah, I hear that, like, because C++ has a bunch of things that can simplify things. Yeah, like take care of 99% of your memory management. Yeah, I've heard that. So here's the thing. Like, I think that it would be like one of these things where I would slowly use more and more C++ features and it would slowly spiral out of control. So you'll notice that my code, you know, this, like, I got a big block of macros here that I'm undefining. All these macros are kind of like, they're section by section, right? All my macros are section by section, and that's because sometimes the macros in a section could spiral out of control. And I used to do my macros file per file, right? But the problem with that is then you have an even bigger list of macros that you declare and undeclare at the top and the bottom of the file. And so this tendency to spiral out of control, I kind of think that, to make an analogy, I think that the same thing could happen in C code, where, like, in one file I use these C features, and I try not to use many C++ features. Then in another file I use a few C++ features, but try not to use too many. And then in another file I use a few C++ features, but try not to use too many. And then slowly but surely I end up just using them all, right? Eventually, and just I'm kind of just scared that it would spiral out of control. So I'm trying to just use something that will be around forever, right? So the idea is that I'm going to code very slowly, but I don't have to worry about the language being taken from underneath me. But I guess with C++, I think C++ will probably be around forever as well. But if I had to bet on C++ or C, which one's going to be around forever, I would bet on C. Though, I mean, they're probably, for all intents and purposes, they're probably tied in terms of how long they're going to be around. But anyways, yeah, I need to create a const char pointer. And this little macro here, neither is going to die anytime soon. Yeah, so so that's good to know, because I am really paranoid, because I spent 2 years writing source code, and then all that source code is just completely useless to me now that I'm not doing anything in ActionScript. Now, I could try to transpile and use hacks, but then I'm using a very niche language that could also die. And so it's like, so I'm like, just screw that, start over. And yeah, so anyways, let's see. I don't know what I'm going to call this thing. str message, and it's going to equal this macro. So I don't know if... I don't know what the problem is, but I'm going to try to... Instead of using this macro directly, I'm going to put it in here. Because I think that there could be something about using that macro directly that's causing me some type of problem. And I don't know for sure. But, right, so this string is a hard-coded string. It's not freeable. And so this function wrapper right here, this CFS macro, it's going to take that string and malloc it. It's going to, like, malloc some memory for it and copy it over to create a freeable string. And that's because the data, this any text data, needs to be freeable. I don't want to mix... I do not want to mix freeable and non-freeable pointers. That could lead to some horrible problems. So, even though this is a hard-coded string, I'm going to turn it into a freeable string so that it works smoothly with the pipeline I've kind of set up here. Anyways, let's see if, let's just see if this compiles, because I don't know what I'm doing here. So I always use kind of like a bash script to compile things. And discarded qualifiers, okay, because it's a const, because I used const char, and I'm gonna guess that it's gonna take a non-constant char. Let's see what kind of macros I hear. Do I have like a macro called nc up here? This is way too, this is, yeah, let's see, char pointer, null string, unsigned char, const char, oh, I just used char for that. Okay. Yeah, this got a little out of hand. Yeah, this did get out of hand. So let's not make that a const char. Let's just make it a char pointer. And I have pretty strict settings on my when I build. So like if we look at my build script really quick. Right, so my build script is pretty simple, right? Just GCC, the language is C. Here's my C file, here's my object file for the output, and then here's all the things to make my compilation a little bit stricter. And then I'm going to compile as C11, I'm going to make a 64-bit executable, and then I believe this is the linking phase. If I need to read more up about compiling and linking, but I'm pretty sure this is compiling and this part is linking. Right, because you can make multiple object files and link them all together into one executable. Remove the object file, run the executable, and right now deleting the executable is removed from the build script right now so that I can use it as a utility while I'm trying to test it out. Yeah. So also the nice thing about C, and to a large extent C++, is that the code that you wrote in 1989 still probably works fine with modern compilers, at least with a bit of simple cleanup. Languages like Python are probably going to stay around, but who knows how long your Python code is going to work with newer versions. Oh, yeah. So I also wanted so pedantic, I don't like pedantic, but I use it because I'll use whatever I can do to make things stricter. Because I think that the stricter you are, the less problems. Float conversion, unused. Do I have unused? So I think... So I do get that warning. I'm going to take a guess. I'm going to take a guess and say that this W extra here, I think W extra includes the unused warnings, I think. Because I know I definitely get warnings about unused variables, but I don't have it specifically specified here. Warnings about unused functions are annoying. Oh yeah, unused functions are annoying. Yeah, I would never do, right, because sometimes it's just like, give me a break, because like I'm in the middle of kind of working it out. Yeah. Yeah, I don't know. GCC is the only thing I really use. It's just, I don't know. It's just, I don't know if it's what I fell into, but, I tried to do stuff with, I tried to use some stuff in Visual Studio, but like Visual Studio has all these like weird things you have to like load into the command line for compilation to work. Cause I got it to work once, but I had to like find a whole bunch of extra bash scripts that had to be like ran before you compiled. It seemed kind of ridiculous to me. It seemed actually I should probably take w unused out of my makefile and just keep w unused function. Yeah, just keep the, yeah. And I know a little bit about makefiles. I haven't really used makefiles in my stuff just because I'm trying to keep the build system pretty simple. Just keep it like a bash script. And I've been pretty crazy about it to the point where like I'm using OpenGL, but I'm like loading the I don't use any libraries in my code, so I'm loading the OpenGL function pointers using load library and get proc address, and then get proc address I load get proc address and get load library and get proc address I get by doing like a little assembly hack to get the kernel 32 address and then find those functions within kernel 32. So I'm not very good at, I don't really know much assembly. I just knew enough to get the address and then wrote some little utility functions to walk through memory to get what I was looking for. But I guess like all executables on Windows are in a thing called a PEB file, and the PEB file always stores kernel 32. So like all executables on Windows, they always have kernel 32 loaded into them, as well as some other like basic DLLs. And so I don't like my code to, I know my code looks kind of weird and it might look cluttered, but I actually don't like code that's bloated, if that makes sense. So Windows.h, I'm like, how can I write code without Windows.h but still write Windows native code? And the answer is, oh, do a few hacks to get load library and get proc address, and then just load all the DLLs you want, and you're good to go. You know, grab the function pointers. But anyways, let's see if I can solve what I'm doing here. And I think that was compiling. Let me give that another run really quick, make sure that's compiling here. Okay. And let's see. So I was trying a command with a whole bunch of gibberish, because if we type an invalid command, I use like a little jump table. Oh yeah, I'm not avoiding kernel 32. That would be incredibly difficult. Yeah. I am, yeah, but I'm just getting, kernel 32 has load library and get proc address in it, so I needed those. There's, like, some others, like, that I use, like, I think user 32, and then I think, for some strange reason, some Win32 code uses GDI 32. I could be wrong, it's been a while, but I swear I was accessing GDI 32 for some odd reason, for like some Windows title bar settings or whatever, for some odd reason. And okay, bad any text length. So something tells me that I don't know how to use pointers. Like, I thought I knew how to use pointers for the last year or so, but my string length is not Can I try to print? So I mean, if if string length is returning 0, then I don't think I'm going to be able to print it. I don't think that's going to help me, but I'm grasping at straws here. I have no clue why my string is not doing it. My string, for some reason, it must be coming back from that function. I don't know what's happening. Like, let me just try to print this off. So, and let's do %d \n, and let's just kind of throw this in here. And I don't think that would do anything. Oh, and actually not %d. So I'm so used to writing decimal values that it's a force of habit where I'm like %d, and it's like, no, it's a string this time. But will that actually yield me any important insight, or will that just be for naught? Let's see here. Nope, that's completely empty, but that makes sense because string length didn't return anything, so, so I'm thinking it's this function. It could be this function, or it could be something else. So, the first thing I might want to do is, we're going to say char pointer, MSG, Freeable. So we're going to take this and we're going to make a Freeable string. Now, we do have warnings when variables are not used, so we're going to do if, and we're just going to take this, and we're going to make a little no-op here really quick to let us not use this right now, but still compile, because any of my warnings will stop compilation, just because I have warnings are errors turned on. And we're going to just take this that does not have any wrapper on it, right? And we're going to remove this wrapper, because I'm thinking that maybe that wrapper function is doing something. And if it's not the wrapper function, then maybe I just don't know. There's the possibility that I just don't know how pointers work, and, you know, I figure that, you know, member access through a pointer. I mean, I know enough to know that's member access through a pointer, so I assume this assignment would be proper. But it could. But the most likely culprit is this macro that's wrapping that string. So I'm going to assume that that macro is the culprit, and see if I can confirm that. And then if I can confirm that, then I'll kind of figure out what's going on with that macro. So let's see. Nothing found, delete me. So nothing found, delete me is actually actually this thing, command not found right here, that's coming from up here. And so this code is not airing out when I don't use this wrapper here. So, or this wrapper function here. So for whatever reason, this function seems to be completely failing me for some reason. I don't know why that is. I thought that I had written this, and I thought I had been working earlier. So now the question is, and I have all these other places where I'm using it, and I'm null term, yeah, I don't know what's up with that. So, I guess what I'm going to do is I'm going to find where I'm using this, and I'll just go underscore CFS and find that function. So yeah, so we have a char pointer to a non-freeable string, and we just want to say string length of the non-freeable string, and then we're going to calloc some memory, blah, blah, blah. Okay, so the first thing I'm thinking is, let's make sure that whatever gets to it actually has a length, right? So we're not doing any asserts on that length, so we should just do, like, you know, if str length is less than or equal to 0, then we have a serious problem. And we'll just take this and we'll say, you know, error and bad strlen, and then the function it came from. Or maybe we want to do it like, doesn't really matter how we write that. We just need to know what's happening. And I don't know if that's the culprit, but something's going on that I don't understand. So let's go through here for a second and kind of remove some breakpoints from other code I was writing earlier. Okay, so now we're just looking at these 2 points. Okay, cool. So let's swap this out again. So let's take so this any text that's this string message, we're going to take the Freeable string and we're going to put it in here again. And then we're going to compile again, and we're going to... Oh yeah, coffee is a good thing. Yeah. Oh wait, hold on. Yeah, later. I understand. I only drink coffee on Mondays. Mondays, I drink coffee, and then I code for 20 hours, because I only drink coffee once a week, so when I drink coffee, it affects me quite strongly. Actually, I need to take a break, too, because it's 9:28, so I have to, like, take drugs. So I need to take a break as well. So I'm going to be, I'll be back in, like, probably 10 minutes.
Germany, June 1921 to November 1923. Highest monthly inflation rate, over 30,000%. Time required for prices to double, every few days. During World War I, like many countries, Germany, then called the Weimar Republic, suspended its gold standard to fund the war effort, based on the belief that they were going to win the war and pay for it by plundering their enemies. That plan obviously didn't work out, so after the war, they were left shackled with not only their own war debts, but were also fined 132 billion gold marks in reparations by the Treaty of Versailles, the equivalent of about $269 billion today. The first payment of that war guilt came due in June 1921. The problem was the treaty didn't allow Germany to make payments in its own currency, so Germany had no choice but to exchange their German marks for other respected currencies at really bad exchange rates. So
All right. So let's I think I was just about to see what would happen here. So this is the Freeable string here. Yeah, I definitely didn't compile this again because you're having a problem where... Yeah, so let's recompile this and see what happens. And... Okay, so compile and run the command with some gibberish. And bad any text length. So I'm going to guess. Guessing is bad. Bad any text length. And that would be coming from here. Okay, so something about my macro, or not my macro, but something about my function. So we definitely can't get the string length. That's all right. And we're gonna malloc some memory, or calloc it to be specific. We're gonna use the string length +1 plus the size of char. That seems sensible as well. Oh, hold on. Hold on, am I being this stupid? I am being really stupid. Yeah, of course this function isn't going to make a freeable string. Do we see any... There's no mem copy here. There's no mem copy. There's no looping through the string. There's nothing here. So of course it's not working. I'm surprised that all the code I have written so far actually even got this far now that I see this. But yeah, we need to just, like, copy. We need to copy the string. We need to do something about that. So, there's a lot of different ways I've seen, really terse ways to loop through an entire, string. Do we want to mess with one of those? So, like, we can do something like while str while strlen minus minus. We could take that string length that we already have, right? And you could do minus minus. So, post decrement, right? So, and because it's a post decrement, when we're not going to use this first value, the length value is out of bounds, but we'll use the first inbound value. And this while is not going to fail until the string length ends up negative, right? Because now is string length signed? Yes, it is signed, so we can do this. Or not negative, but right. So if this was at 1 before it got into here, it's going to be evaluated as 1, even with this. and then we use a 0, if that makes sense. So we should be able to just do this, and then we can just say, you know, str out, str len equals oh, it's an assignment, so equals str what is it? I called it non-freeable string. Well, that's a mouthful. But yeah, equals non-freeable string, whatever the heck, right? So we could also do like a mem copy, but I feel like why do that? Why do a mem copy when we can just literally write out exactly what's happening? And right, so we can make a note of that, right? We're just copying the string. All right, we just want to copy the string contents, and that should be all we need to do. And let's look over here for a second. So we're using the Freeable string here. Okay, good. So let's clear this and see if we can compile. Okay. Okay, nothing found, command not found. So that command not found is this, you know, not found, this not found right here. So yeah, it was the create freeable string that was giving me the problem, which, so this is kind of a mess now because I kind of like, do we want to keep all these checks? I'm going to keep all these checks, but I'm going to get rid of this. This is too bulky. But I'll keep these checks in here. And yeah, so we're just going to have some little checks here to... also, we'll get rid of this thing here. This nothing found, delete me. We're going to get rid of that. Okay, just clean it up a bit. And then we will compile it, give it another run, and see what it looks like when we feed it some gibberish, right? So if we feed it some gibberish like this, we get command not found. Great, that's exactly what I wanted. So now the next thing I want to test out is if we do like, well, let's do the actual command that we know works. So if we do PNG to naked text, right? So PNG to naked text, and we use logo.png. Yep, there, we got like a little hex dump here, right? So we got the hex dump of the file. Now this is printed to std out, but it also is printed to a file. So so this PNG or TXT, if we open that up really quick, we can see, oh, there's that hex dump that we saw in the console as well. Now we may want to change those kind of settings later to be like, maybe we don't want to flood the console with that kind of stuff if we're putting this into a build system. Now the next thing is, well, how about if we do the opposite? So we take naked text to PNG, and we know it's in the PNG or TXT file. Try that. We see fatal error, finish this algorithm, right? So now we're at the point where if we want, we can start to write some logic in here for that algorithm, right? So we have checked the input, so a lot of crazy input checking. So what exactly do we have here? We have the naked text, the length of the naked text, and then we have our outputs, our by ref UO8 array and our by ref array length. So we have it all set up, and we even have it set up for once we figure out, right now these are null pointers, right, because we don't know what they are yet. Once we figure out what they are, we'll use this dereference and assignment here to populate those output parameters. So we're all good for actually figuring out the logic for this. So what do we want to do for parsing? So I think that when we're parsing a file, I think what we want to do is we just want to keep a little array of 2 different letters, right? Like a little array that just has 2 different letters in it. And that array is going to be like a sliding window. And that sliding window, that sliding window is just going to go over the data, and whenever it collects two values that can be valid hex, it's going to use them. So something like, so we know that 0x is not valid, right? This. So we want to avoid a situation where we, let's say we have something like this, 0x ff something something, and then later we have like this 0x ff. We want to avoid using these two together to create like a f0. We want to avoid accidentally parsing like that. So how are we going to do this? There's plenty of ways we could do this. I'm thinking the simplest way would be to ignore 0x, right? So to be able to a 0 or a x should be able to be put into if it's, so here's my thought. If it's 0 through 9, if it's 0 through 9 or A through Z in terms of ASCII characters, then we use it to fill this queue of just the scrolling queue, the scrolling window of two letters. And if we find that what ends up being in there is a 0x, we just toss it out and we ignore it, right? So when we're parsing this, that's how we'll do it. So let's first, so when we got to think about this algorithm, let's write a section here and say, you know, main function algorithm, right? So main function algorithm, right? And in this main algorithm section is we're gonna like write all of the meat and potatoes of what we're doing, and so we don't have much room here. But we're going to first of all iterate through every single character slot. That's the main thing we want to do. So we have this text and whatnot, and we're just gonna say, you know, loop through it forward, like loop it from the beginning to the end. So we're just gonna say, like, you know, for dex. So dex, right? Just a generic index equals 0. Dex is less than or equal to max index, and dex is plus plus, right? So. And we'll actually glue, we know this, we could start running out of room really quick, so we're gonna glue this onto the main algorithm section, just because I feel we're gonna run out of room, so we might as well not indent too much here. So we know that, that the int32 dex, and then we also have a max index, int32 max index. And do we want to make a, do we really want to do a declare and then an assign section, or do we just want to say, you know, max index, well, you're going to be equal to the length, right? The length, and then -1, right? So that gets the max valid index. And this index, we can just set it to 0, I guess. I mean, doesn't really matter because we override it here. Okay, so now that we're here, we need some type of scrolling queue, right? So we're thinking we have this scrolling queue, and yeah, we use the scrolling queue, but when we come across, so if we come across, so 0x, ff, 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 and then we have like spaces or comma, 0x, ff, 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 right? So if we come across spaces, right, we ignore them. If we come across commas, we'll ignore those as well. so we are going to rely on everything being, we're going to rely on parsing this based on everything just being correctly, like, so if we parse the way I'm thinking about parsing, then this, if we're using an array of uint32s and we have this and this in a list, this would parse improperly because it wouldn't have collected enough. Well, actually, no, we're turning this into bytes, so it actually wouldn't matter, would it? Yeah, because we're gonna take the hex dump and we're gonna turn it into an array of bytes using network byte order. So actually, that wouldn't be a problem. Okay. So let's just create like a scrolling window. So let's say it's a U08, and we're going to call it a window. And it's going to have 2 elements in it. So scrolling byte window. And this is actually going to be a char, right? And char as in, yeah, just char. So this is going to be for the char values. And when we're collecting things, we need to know where this pointer is going to be, right? So if we have something valid, we're going to say, you know, the scrolling window. We could call it dex and then window. Or we call it windex for window dex. Or we could just call it WD for windex, right? So CH, or it'd be DW for dex of window. DW, and this would be an int 32. I'll call it DW. So DW, and that will equal so post increment, right? So the thing is, if we post increment like this, it makes the code confusing, and then also what happens when it rolls over. So, I think DW, so it's going to rest on the empty slot that needs to be filled, and DW equals, we're going to take this text, right? And then we'll do, you know, DW++. And then actually no, DW equals DW+1. But then we're gonna mod 2, right? So DW+1 modulus 2. Right? So if so 0 1 0 1 0 1, right? That's the way we're doing it, right? And now the thing is we want to only collect certain values, and right now we're going to collect any so instead of this naked text, what we're going to do is we're going to say dex of we're going to create a char of called current, And the current character value is just going to be cur equals the naked text and the current dex, right? Now, the reason we're going to do this is so we can modify cur, and we can say to uppercase C. Now, I thought there was a, or maybe it was called UKC. How about upcase C? So the other thing is that there's possibly I haven't reloaded my shortcuts. So I think it's called like 2 upper and 2 lower. In C code, I think it's called 2 upper and... Yeah, it's called 2 upper. And there's 2 lower. So use 2 upper in C type so while we're here trying to make these shortcuts for 2 uppercase, we might as well do the same thing for 2 lowercase. So let's take all of this nonsense here and say, okay, anywhere we see upper, we're just going to replace that with lower, right? So anywhere we see upper, we're going to replace that with lower. And then we have these other ones, which is like L case. So upcase, how about lowercase? Right, so we have some synonyms here. And let's kind of like put this all in one line. So you have some synonyms for this next time we want to come back to it, right? And then we can same thing with here. We can kind of go barg. And we're fairly certain it's 2 upper and 2 lower. Let's make sure that that is the case, though. So if we do 2 lower, two lower C standard library, yeah, so that's what I thought it was. Let's take that, let's put it in our master notes file for later. And also, I need to jump on the trampoline. So I think at 11 I'm going to stop this stream so that I can get all my exercise quota done for today. But yeah, so this current, we can do this, but then we can say that, you know, cur equals 2 upper. Right? And we can modify that value. And then it'll be easier to check the ASCII range of the value, right? So now, if we look at an ASCII table, and we're trying to figure out, well, what values are we trying to look for, right? And so we're trying to look for A through F, but we're also trying to look for X. So it would be easier to just to look for 65 to 90. 65 to 90? So, you know, if cur is greater than or equal to 65, and cur is less than or equal to 90. Alright, so if this is the case, the other case is, or cur is a digit, and the digit is 48 to 57. So yeah, so 65 to 90. 65 to 90. And then 48 to 57. 48 to 57. So if it's any of these, then it's one of the values that we're going to allow ourselves to look at. So no commas and no spaces. So if that is the case, if it's one of these things, then we're going to do this thing here, right? And so if dw well, hold on. So we need to keep track of, we need to know when this is flipped over, right? So well, actually, we need to know when it's filled, right? So if 1 equals dw, right? So if we filled both slot 0 and slot 1, then it's been filled. And if that's the case, what we want to do now is we want to if it gets filled, we want to analyze those values and see what we have, right? So there's like a STROUL I think it's called this, or it's something like this, right? Unsigned long int. I don't know what end pointer is. This is a reference to the object of type char, whose value is set by the function to be the next char in str after the numeric value. Okay, got it. So we're gonna give it a null pointer. So we don't care about that. And and what library is this in? Probably stdlib.h. So what header is this? Okay. stdlib. Okay, it's in stdlib. Okay. Just making sure. So... So... I'm gonna just take the... We're gonna take... Okay, I'm just making a little snippet for myself for reference later. Okay, so I'm pretty sure that the way we want to do this is something like this, right? So we're going to take our string, and the string will be that sliding window itself, right? The sliding window itself. And we want base 16. We have another problem here, that first we need to make sure that we have valid characters, right? So we said 65, we gave this much bigger range because we want to be able to, if we see like a 0x, we want to filter that out, right? So if, so we know we uppercased everything, so to keep it kind of simple, this parser is going to be rudimentary where it could fail with a lot of bad data, but if when dw, right, so if we're assuming all the data is going to be nicely aligned. Alright, so we're going to assume this condition, else okay. So if 1 equals dw, we do stuff with it, right? Because it's filled up, but then dw is going to get set back to 0, right? Like, after we're out of here, dw gets set back to 0. So dw... So let's think about how this works. So it feels kind of weird that, the first time it equals 0. So the 0th equals this current value. Then dw equals dw plus 1 modulus 2. So now it's 1. If 1 equals dw... Okay, so no, if 0 equals dw, right? Because... because when 1 equals dw... that's just kind of hard to read, though. So actually, what we should do is... it would make more sense to do this. Right? Where we put this on here, right? So dw 0th equals this thing, and then the next time around, it's going to be... we're going to have use the next dw, and then if 1 equals dw, we're here. Right? And if 1 equals dw... we do some stuff, and then dw equals dw plus 1, right? And then we don't need to zero this out, right? So now, if we do that, that'll work. So the next thing is, well, why not just put that at the top, like this? Like this. Now the problem with that is dw needs to start out at 1. Right? DW starts out at 1, I think that would work, right? Because then DW plus 1, that gives us 2, that sets back to 0, and then we fill it here, right? So it's at 0. And we don't do any of this nonsense. And the next time we hit something, we increment it, and DW is 1. And DW equal to 1, well, then we want to do all this stuff. And then next time we use it, we're going to have 0. So yeah, that looks about right. Okay. And we're going to need to do this twice, aren't we? Because we need 2 phases. So now we could make just 2 loops that do this, right? I think that would be the easiest way to go, is to just have 2 loops. That would probably be the easiest way to go, yeah? Yeah, I think so. So instead of this, we're just gonna say we'll just count the number of bytes. I think it'd just be, I don't want to write all this logic twice, though. So let's just do it this way. Okay, so what we'll do is we'll say this array here we'll have to allocate it, but if get is greater than or equal to 1, then no, so we're not going to use the array len. We actually need a bit counter, a byte counter, because yeah, that just makes more sense. So we're going to do it that way. And So in this getter, if get is, if we're on the second pass, then we're going to malloc that memory that we need. Alright, so we're going to take this array here. I'm going to say that, you know, the bit counter will set to 0 here, which will be incremented here. And then we can say array length equals the bit counter that we used earlier. And then we can say that, yeah, you know, that this data here so total number of elements, and then the size of one element, well, it's just going to be a char, right? So CHR. We're just going to calloc that memory, right? So if 1 equals get, we're going to calloc that memory. Otherwise, we do nothing. And this bit counter needs to be set to 0 here. I keep on saying bit counter, but I mean byte counter. And this byte counter, is that correct? Or is it counting bytes, or is it counting... Yeah, it's counting bytes. Okay, cool. So byte counter, cur is the current character. Yeah, so current character, and then we have the byte counter, right? So byte counter is 0 here. Get is between 0 to 1, right? So it's on the outside, and then we do this main loop here, and let's kind of cluster this a bit better, like that, yeah. Actually, I think this do nothing. I don't know if I like this do nothing. I think it's just clutter. Byte counter is always set to 0. If it's within... So this is A to Z. Okay. We have A to Z, and then we have 0 to 9. Right. And we don't really need the Z's and whatnot. We're just hoping that there's not going to be any Z's in our data set, otherwise this parser will probably fail us. So DW here. Where do we set DW? DW is set to 1 here. It's going to make more sense to set DW right here, right? Because then the loop entry is going to be more consistent, right? So DW equals 1, right? Because if we set it here, there's a chance that when it iterates through here again, it's not going to be consistent. So let's just not even assign it values here, because that's just going to confuse us. And we can make a note here. I mean, we probably already said, byte counter is reset to 0. DW is set to 1 because we kind of increment it right here like that, which is kind of weird. But the idea is that it just makes it a little bit more clear for this right here, right? Because if 1 equals DW, if it's full, then we're ready to analyze it. So, dex so we are kind of being a little bit different here, where we're resetting this to 1, right? So we want to make a note, reset this to 0, but reset this to 1. And then here's where we're going to collect the data right here. But before we collect it, we'll have to calloc the memory here. We're going to use the byte count, or the byte count. And that byte count starts at 0. Every time we find something, we increment it here. This thing only gets executed. Yeah, so I think that would work, yeah. Are you missing anything? I don't know, I think that's the basic algorithm we need. It's not really that complicated, is it? Yeah, it's not that complicated. In fact, it's so simple from the other stuff I was writing that it kind of scares me how simple that looks. But yeah, I think that will actually be what I need, so I'm kind of scared to run this because it just seems deceptively... It seems like deceptively simple to where it's like, oh, come on, there's no way I got that right, kind of a thing, you know what I mean? So, let's, kind of, like, execute this. Let's execute the... So, get is... undeclared get. So we have to do it in 2 passes, right? So we might want to make a note of which video this was written in. So we could make some notes here and say, right, so right here is where we just made the first draft. We've just written the first draft of this function. Maybe I should have put more timestamps to explain what I was doing here. But if you want to know, like, where we... At least this will give you a good idea of where to go if you want an explanation, right? So you got to go to the first draft and then rewind in the video to see what all this stuff is here and what this algorithm is all about. But I can explain this first draft for a second. So we're going to have 2 loops here. We have this inner loop that loops through the string, and then we have this outer loop that either doesn't get or gets, right? 0 for not getting, 1 for getting. And in this loop right here, we're going to loop through every single letter in the naked text, every single ASCII letter, using this dex to get the current letter. Then we're going to convert it to upper, so cur equals to upper cur, right? Then once we have this uppercase value, we can look at the ASCII range and say, is it between A or Z capital, or is it between 0 and 9, right? And if it's one of those letters, it could possibly be a hexadecimal value. So DW is always initialized to 1 at the beginning, so that if we add 1, it becomes a 2, modulus 2 ends up back as 0. So the first value of this is 0, so we fill the first slot of this sliding window to the current value. Now, if we're at the second slot, where 1 equals dw, meaning we've filled the second slot of this sliding window, meaning the sliding window is completely full, then we're going to say, hey, sliding window, are you... so this is wrong. Sliding window, are you 0x, right? So this is just a quick way to say, are you 0x, right? So, you know, like 0x of 0x, right? That's what this is looking for, right? It's looking for a 0x of this kind of thing, right? And if it's that, we're not going to use it, right? It's just a fancy prefix thing that we don't need to parse the data. Now, otherwise, if it's not that, we are going to assume assume data is valid 2-digit hex, right? So we're going to assume right here. Right here, we're assuming, okay? If we don't get valid data, we're going to be in trouble. Now, the reason why we can assume is we filtered for these letters. Now, Z obviously is not a valid hex letter, so if we have Z's in our code, then it's going to fail. And the reason why there are Z's in here is because, well, we want to like filter out the 0x, and in order to filter out the 0x, we have to match for letters that are not valid hex, right? So, we could actually, if we wanted to do this a little bit better, and have it a little bit more robust, I think what would make more sense, let's look at an ASCII table again. So I think that it would make more sense to match for A through F. So 65 to F is 70. So I think it would make more sense to match for A through F. And then also match for specifically or specifically, actually, we could have just used, oh, too late now. So we can also match for explicitly X, for the 0X, right? Alright, so we can get a little bit of tighter matching where, so let's make a note of this. @vid id and 0126, and the time is 2 hours, 51 minutes, and 6 seconds. Must match X, so we can throw away X and not accidentally think. So the reason why we have to match for X is because when we're parsing through the data, we don't want to, 0 is a valid value, right? 0 is a valid value, but X is not. And when we're parsing through that scrolling window of data, we don't accidentally want to collect, so we don't want to do something like this. We don't want to say, well, let me just explain it over here. We don't want to accidentally take, so here's 0xFF. We don't want to accidentally take the 0 and the F to get 0F, right? We don't want to accidentally do this, right? So 0xFF, we don't want to accidentally get this. So that means we have to take the 0 and the X and put it into our sliding window so that we can detect this 0x here and say, oh, that's 0, it's actually part of a 0x. Ignore it, right? So that's why we need this X right here. Otherwise, yeah, we can make the comparison tighter and search for only A and F in 0 through 9. So now if you had a stray Z in the code, like you could take this and parse it, and if you put some like spaces and a Z, you'd still be good. The parser would still work properly. So you could have slightly malformed data, and it would still work. Okay, so what else do we have here? Okay, so once the window is filled, right? Sliding window filled. Right, so that right here means the sliding window is filled. And if the sliding window is filled, no, let's not clutter it up too much. So if the sliding window is filled, right, we're going to discard the 0x. Otherwise, if we're not on the get, we're not going to do any of this. We're still going to count the byte, the current byte we're on, the byte counter. Otherwise, we use the byte counter, which is initialized to 0, to fill the first slot of this U08 array. And the way we're going to do it is we're going to take str to unsigned long, and we'll take that scrolling window that creates a little character value, and we'll parse it. Now the thing is that we should probably null terminate this. I don't think this is going to work properly unless it's null terminated, now that I think about that. So let's go back here, and we're going to actually give it a 3. And we can just do it here, right? So when 0, 1, and 2, so not a char pointer 0, but just a casting to char 0, right? So we need a null terminator on here, right? So this window, we only use 0 and 1, but we need 3 entries because 0, 1, and the second, 0, 1, and 2, the last one we just need a null terminator to make sure that we do not, that we parse it correctly. It's not that, or we could just do a 0. We don't really need to get that fancy. No, let's leave it like that for now. But yeah, so this window, we want to make absolutely sure there's a null terminator there on the end. And, if we want to be really paranoid about it, why don't we be paranoid about it where it actually matters, right? So there could be a whole bunch of things that change between then and now. So if you want to be really paranoid, we could do it right here, right? We could say, we could put the null terminator right here. So when here, and then we parse it right here, and then we're good. Also, this needs to, we need to remove this from here. That's not quite right. Okay. So that looks about right. We could also put this over here, yeah? Not quite enough room for that. We don't really need to call this a void pointer. Though I do like calling it void pointer. I think it makes it easier to read. There we go. There we go. Right there, right? We're just kind of like on that edge, living dangerously. Okay. So now we're on a second draft, and we haven't even ran it yet, but we already found some mistakes by thinking it through and reading the code, which, you know, reading the code is a good idea. So let's make a note here that so we're on video 0126, and the time is 2 hours, 57 minutes, and 52 seconds. We're on the second draft. Second draft is finished. The second draft has just been finished, right? We went through the code, read it again, and found some mistakes in our parsing. But let's read through this one more time. So we got some checking of inputs. We got some variable declarations. We have the array we want to fill with byte values, the array length as 0, the index for looping through the string, the maximum index for the string, which is just the length of that string minus 1, a scrolling window that we're going to use 2 slots of, but it is declared as 3 because we need a null terminator in it so that we can correctly parse it into a byte value. So we're going to take like an ASCII hexadecimal value and parse it into a byte value. DW is the index of the window, so the index into here. So this DW is either going to be 0 or 1. We have the current character value, which is going to be the current character value in the string we're parsing into bytes. This is the byte counter. It's the it figures out how many bytes are in the string as we're parsing over it. Not bytes in the string, but like this. Like if we have a string, right, this string here may be 2, 4, 6, 8, 9, 10, 11. This string may be 11 characters long, but it contains 1, 2, 3, 4 bytes. So this byte counter is figuring out how many resulting bytes are going to be deserialized. So deserialized byte counter, right? Get is just a flag for, are we doing a first, we gotta do this in 2 passes. We're gonna do 1 pass to figure out how much data we need to allocate, and then the next pass we will allocate the data, and then we will populate it, right? So this is a 2-pass algorithm, right? So right here, if 1 equals get, then the array length will equal this accumulator, and this U08 array will be a calloc using the array length and the size of char, right? We're creating a, not a size of a character, but a size of a U08, right? Because this is a U08 array. So I made another mistake after reading it for the 3rd time. So this byte counter gets reset to 0. It only gets incremented when we accumulate a valid code that can be converted into a byte value. The index of the window is kind of weird because we reset it to 1, and that's because the index of the window, we do this logic right here before we use it to access the sliding window and put that current ASCII value into there. And the reason for that is because this just reads a little bit better that way, right? If 1 equals DW, meaning this window has been filled because we have either slots 0 or 1. And once you've filled slot 1, then we have 2 characters and we want to analyze them, right? We want to analyze them and see what we have. And then after we have this 1 equals DW and we're outside of here, we can just keep it at 1, right? Because it's 1, we flip back over here. This is going to make it roll back over to 0, exactly where it needs to be. Okay, so this right here, if get is greater than or equal to 1, right, if we're flagged as getting, it means we have already allocated the memory. We're going to make absolutely sure we have that null terminator in case something happened in between. It doesn't look like anything has, but it just this seems like the clearest place to put this code, even though it is redundant, right? It's not efficient, but it doesn't, I don't care too much about that, the lack of efficiency from setting this value over and over again. I think the most important part right here is just the clarity, knowing what's going on, right? So we're going to take this current slot, right? So this is the byte counter. The byte counter was initialized to 0, right? So the first time we use this, it's going to fill the 0th slot, and then we increment it, right? Because if there's one thing in the 0th slot, then the byte count is 1, right? So that lines up correctly. So this parsing, we're going to use the sliding window. So this 2-letter string. This part we don't need. It just helps us traverse the string if we want to, or something like that. It's a pointer. And I know we don't need to use this, and we're going to use base 16. So if that all works out correctly, we should be golden. So okay, so I would say that now we're on a third draft, because this is that, that's that. Let's make sure that this is correct. Hold on. So we got these, and are they set everywhere they're supposed to be set? Array length. Yeah, so I'd say that's good. Let's go over here and just make another note. So, @vid IID. And it's 3 hours and 3 minutes and let's say 23 seconds, because I like to contribute to conspiracies. So there's like a 23 conspiracy where 23 shows up more often than it should, and I feel like I can help that. Yeah, exactly, yes, the Alex Jones thing. I don't know where I found the 23 conspiracy or whatnot, but I think it's funny that, like, is it a conspiracy, or at some point did people, like, just grab onto the number 23 for some weird reason, and now people start propagating the conspiracy, so it's an actual conspiracy, because a whole bunch of people like me are just like, ha, I'm gonna put 23 in here and put it in random places just so that the number 23 shows up in a higher frequency. But yes, I like the poor Alex Jones getting banned. Hey, I wonder if I can find this. Gay frogs. Let me see if I have this. There we go. Bam. Even though you've probably already seen that, but I got a shortcut for that, cause yeah, why not? So I think this algorithm is ready to run, and if this works, then we'll be done with this. We'll have, well, I mean, we're not completely done, but now we have the thing I care about most, being able to take a PNG file, convert it to a hex dump, and then being able to do the reverse, take that hex dump and reconstitute it into a PNG binary. So I'm kind of nervous, because I'm like, that was a lot of code to write. Let's just implicit declaration of functions. So we have to actually include this, so that's fine. So let's go over to the C11 file and just go up to where we're including things. So to upper, to lower. Stuff I think I need for makedir command. Okay, so we're just going to put it in here. And it's like, I thought it was stdio. I thought it was an stdio. Am I wrong here? Hold on. stdlib. No. Well, there. Did I type it wrong? There's stdlib.h. I probably typed it wrong. I probably don't know what the hell I'm doing. So let's take a look at that for a second. And check some documentation. So I thought that was the name of the function, so I don't know why. I'm gonna move this over here. STROUL. STRTOUL. Is that what I'm messing up? Okay, so I got another solution, which is called look at some other code we've wrote and see how we did that. So in the R drive here, I have a kanji coder folder here, and I don't even remember which one of these is. Maybe I should not write things in such shorthand. I think it's this guy here. Let's look at this code and see what this looks like. Yeah, no explanation of what this code... I know that I have a short explanation of this, like, on my GitHub. But, let's look at this really quick, because I bet if we find... let's go str and see if we can find the word str. Yeah, this thing right here. So, strtoul. Okay, so I was close. So I just don't know. I just don't know what I'm doing. That's the answer. So I'm just putting some notes in my shortcuts for this. I want to make sure that I recognize that I have typed this wrong. So these are the misspellings. So I'm going to take these misspellings and I'm going to put them in a shortcut here. And I'm just going to tell myself that I don't know what I'm doing. So okay. So some of these C function abbreviations, I'm like, I don't know what the heck they are. It's confusing. Okay, so we know this is the actual function name we need. So that's all I needed. That's all I wanted to look at. So it's this function name, and we can just change the indentation there. That's looking a little bit ugly, but let's just get it compiling. And first step, get it compiling. Second step, hope that it doesn't crash horribly on us. So let's look at, let's close this. Let's make sure that this file still contains like a nice little hex dump. So it doesn't contain the hex dump yet because we need to actually invoke it. So PHEXDUM.exe, and we're going to do PNG to naked array, right? And then we're going to take the logo.png, right? So we're going to do that. We're not going to specify the output file that's going to be provided for us. So let's try that out, see what happens. So bam. Okay, so now we got a nice little hex dump. And I believe... Hey, so I'm writing the other, writing the reverse of what we did on... Yeah, so I am doing the reverse of what we did on Monday. I don't want to code for too long, but I'm like getting really close to getting this done and over with. At 11 in like 10 minutes, I'm gonna have to go jump on the trampoline for 100 jumps, because like I got all my push-ups for today done, but my week total has hit 500, and every time that week total hits 500. Not 500. Every time the week total hits an increment of 100, I go and jump on the trampoline for 100 jumps, and I haven't done that yet. So I've done all my push-ups and crunches and things for today, but I haven't done my trampoline yet. So I have to go do that in about 10 minutes. But right now, we are taking this hex dump, and we're going to try to run the inverse command on it. So I just want to verify that, indeed, there's a hex dump in there. And then I want to just run the other command. So we're going to say, instead of PNG to naked array, we're going to go naked to PNG. And then we're going to try PNG or txt dot underscore underscore underscore. Horrible, horrible name. The idea is that this default file name may... I'm tired. Yeah, I got ya. Yeah, I'm... so I'm usually... I usually don't get motivated again until about Friday. Yeah, it takes me until like about Friday to get motivated, and then Friday and Saturday I start coding, and then I get excited to write code, but then I can't code on Sunday because it's like my break day. So it's like, so I don't know. I question my use of coffee. I think, like I said, I think my coffee habit just redistributes my productivity. I don't think it makes me more productive. It just redistributes. But I like the fact that when I only drink coffee on Monday, like I have this guaranteed day that I'm like, I'm gonna get shit done on this day, and I'm gonna like it, right? So that's good. So let's try this and see what happens. Horrible, horrible things. Will save to disk, and then assertion failed. So we got some good things going here. So will save to disk is saying that the message that you usually see is, you know, something like this that we can print out to the console. But in the case of creating a PNG binary file, We're not going to try to print that out at the console, so I had this little message that says will save to disk, but I had an assertion fail, and let's see, assertion failed, line, okay, let's just go to this line and see what's going on here. And since the assertion failed, what we're going to do is we're going to change it from an assertion to like we're gonna change this assertion to, okay, so this is kind of a weird assertion. Yeah, so yeah. Yeah, it's always better that when the code fails that it's always great when the code fails, but your assertion catches it, right? So like, as long as the best possible thing I can hope for is that I write bad code, the compiler catches it. I write some more bad code, my assertions catch it. And by the time my assertions catch thing and the compiler catches everything and I fix all those problems, the code works, right? And then I don't have to pull my hair out and wonder where things are going wrong because my assertions... Yeah, exactly. So this assertion is kind of weird. So it's saying that if I have a payload is the result of... You know how you said yesterday or Monday, you said like Tuesday or Monday, you don't like to mix characters and byte arrays, right? You don't like to mix those. So I haven't totally fixed that entire problem of not mixing things together, but I've done this hackish thing that should be a union, but it's not a union, and I've made this payload object. So let's go find this payload object. So this payload struct right here. And this payload struct has a tag. This tag can either be positive for being text, or it can be negative for being a PNG file. And if it is flagging for a text file, then we have an ASCII array, like a char array. That's what this macro is for. And we'll use this one, right? And then if it is flagged as a PNG file, then we'll use this pointer. And so this could go into a union, because I was thinking, oh, we could just make this a void pointer, and then this flag tells us how to interpret it. But then I'm like, actually, that's not correct, because that would violate C's strict aliasing rules, right? Like, if we had a void pointer that sometimes stored UO8, but then sometimes it stores char, it probably wouldn't cause any problems for us, but it wouldn't technically be correct C code. It wouldn't be well, what do they call it? Well behaved. Yeah, this thing right here, because of enum. Yeah, exactly. Except if it's 0. So I see what you're saying. I totally see what you're saying. But I have one counter argument. I have one batshit crazy counter argument to what you're saying there. And the counter argument is that 0 for this is an error condition, right? So it has to be 1 to be any text, and it has to be negative to be PNG file. And the reason for that is because that way I can, when I instantiate one of these payloads, I can 0 initialize it, and when it's 0 initialized, bin.txt essentially has a trap value in it, right? And I like to make things in a way so that when they are 0 initialized, they're as invalid as possible, if that makes sense. I try to make it so that when you 0 initialize, everything is as everything is in an invalid as possible state when I 0 initialize, because that helps me catch more problems. But yeah, yes, you could use an enum there. The thing that bothers me with enums is that you don't have a guarantee of what it is, right? You, like the implementation defined. So it's like, I want to make sure that I know that it's invalid file equals 0. Okay, oh, okay, counter. That's a good counter. So the other thing is, like, here, okay, here, if you want this, here. Okay, we'll do, since you're here, I'm only gonna do this because you're here. Sure, let's try this. Now the thing is that I use int32 a lot, so this could break some stuff. But here, since you would like to do this, let's okay. Okay. Payload file type. And I am actually going to change these names, though. So, because right now this is going to be any text, and this one's going to be PNG file. Just because 7 letters and 7 letters is just a thing. And invalid. Well, isn't that nice? Because it's already so enums, are they like in other languages where it's just going to be sequential from the last assignment? So this is, since this is 0, this is going to get a 1, this is going to get a 2. Now the thing is that I've already set, you know, negative for this, positive for that. Okay, it is? Okay, cool. So we'll have to change this around, right? But we can do that since you're here. So this bin txt, let's see, so that means that this would have to be, how about pft payload file type, and then let's just go payload file type, and then down at the end of the struct, we'll undefine that. Okay, payload file type, PTF. Oh god, see, oh god, so dyslexia is a thing, and this is called me being, PTF is not PFT, so, we're just gonna call it, let me think about this. I'm gonna call it this just because I'm just gonna call it that because I cannot be trusted to put 3 consonants in a row without screwing things up. It's just a thing that I do that I'm just not very good at. So we're just gonna call it this, and then we're gonna have a lot of places where we're gonna need to fix things though. So we need to go in here for a second. And right, so anywhere we have this int32, right, we need the payload file type. So I'm gonna try like PT for payload type. How about that? Because if we do that, let's see if I'm using the macro PT anywhere else. Match whole word. Okay, I'm only using it here for now, so that's good. So that way I don't have to worry about it too much. But yeah, so anywhere we see bin txt, we're just gonna replace it with so greater than equals to 1, so is text. So we're gonna change this to now how does that work? Does it use a dot operator, or how the heck does that work? Oh no, hold on. Do we have to namespace these out? Hold on. Wait. Do I have to hold on. So, hold on here. Does this have to be... So, I think this might be another reason. Don't I have to do this? Like, I have to go, like... I don't want collisions in my code, so don't I have to do something like this? I have to do, like, this nonsense? Like, I need some type of namespace on these, right? Like, I need to, because otherwise these become, if I don't put something on the beginning of these, then I can't use them anywhere else. Like, am I understanding that correct? There's no scope. Yeah, that's what I thought. Yeah. So yeah. So this is how I have to do it. Okay. Okay. So I understand correctly. So that means, yeah, I can keep this as payload type. That's fine. And so this is gonna get kind of yucky. So let's try to shorten that. I'll just do PT for payload type like that. That's a little bit shorter. And then we're gonna say allocate memory, define. Okay, any text, so there, that just barely fits within what I'm doing. But that makes using the constants a nightmare with such long names. Yeah, exactly, yeah. So now, so in retrospect, you might see kind of like why I did it that the other way. But, we can do this and just see, we can see this through. Alright, so PNG file. PNG file, any text, yeah. And then we can undef this. And I'm already indented way too deep, so, I forgot why, but my indentation doesn't automatically go back to where I am. But it's not really a bad thing. I didn't intentionally do it that way. I think it's because my syntax highlighting is just... My syntax highlighting thinks this is a plain text file, so when I indent, it goes all the way back to the beginning. But that also is a good reminder of how far deep I am. Like, I'm nested way too deep, and I am constantly reminded of it because I have to go tab. So it's a reminder of the horribleness. So is text. So we're going to say... Alright, so we can say that this is text, so any text. Right? And we're not using that. Yeah, okay, so this macro here. So we're going to say, call this any text, and then PNG file. This is for not text, aka PNG file. So we got our text file, our PNG file, and then let's look for more places where we're using bin.txt. So bin.txt here, so we need a macro for the payload type, payload file type. So we're going to go, so I already have this payload struct, so I think that define PT right here would probably make the most sense. And I assume you do enums just like you do structs, right? So you have to say enum whatever the hell whenever you're doing it. If I wrote more than 3 levels of indentation, I would fire myself. Yeah, like, I try not to indent too much. I don't know what happened. It's like I try to keep my code really terse, and I do try to avoid indentation levels like that. So this is not what I would call flagship code, or whatever you want to call it. It is not definitely not my best work. Because I also try to avoid it. Now the thing is, it's hard. It's sometimes hard because I gotta think. I want to avoid excess indentation, and I also want to avoid breaking things up into too many helper functions. But breaking things up into helper functions is one of the ways you can get rid of excess indentation. So it's like I don't know. We can look at it and see how I got to this mess. So payload file type. And let's look at bin.txt again. So this is going to be a payload file type, so pt bin.txt, and it's going to be, this is not text, so that means that this should be for a PNG file, right? So we're going to do PNG file. And then up here we're going to say define, and we can take this PNG file value, and we can say PNG file okay, and then we'll undef PNG file down here. Okay, and now we gotta look for more places where we use this. So bin.txt, that's fine. That'll have to be changed though, so find next. Bin.txt is any text here. Oh, hold on. So here's the other thing that's gonna screw me over. Is oh, maybe not. Any text. Oh, god damn it. So the other thing is, you know how you said enumeration? I already made it enumeration. I just didn't, this is my enumeration right here. But it's not an enumeration. It's not a proper enumeration, right? Like, it's not an enum, right? It's just this and this. So the reason why I use this and this is because I get a guarantee that, oh, this is, I know that this is a 32-bit integer. Yes, so bootleg, whatever, yeah, so, bootleg enum. So usually this is how I write my enums, right? I just say that ENU stands for enum, and it's enum any text enum PNG file, right? But let's say 0126, time is 3 hours, 29 minutes, and then I actually do have to jump on the trampoline because it's 11 something, so, but first let's finish this thought. So we can take that there. We can just paste that in there. And for now, we can take this and we can mark it as deleted. Yes, I mark things as deleted by just making a red comment. And so wherever we see this, we're just going to refactor it. So this enum for any text, we're going to take the new any text enumeration and bam, put it there. So put that there. And we're going to keep on looking for this bin.txt. So now the thing that's kind of scary is that now I'm kind of like going everywhere and kind of like changing things. And if I get these enums wrong, then bad things are going to happen. So this is text, right? This says, yes, it's text. So we want to take the any text enumeration and we want to put it in here, right? So this thing right here, right? So any text. And it looks like we have enough room where we can just put that in there. Sure, why not? And we're going to keep on just going through here. And I have too many things open. We really should not leave this half refactored, though. That could be disastrous in my experience. So, PNG file. This is PNG file. And this enumeration we're not using. We just commented it out. So, this is the PNG file enumeration. We're going to take this, paste it right there. PNG file. Good. Okay. So, let's look for more places where we have this bin.txt. Bin.txt any text, and this any text here, we see this bootlegged enumeration here, so that means that we're going to have to take this any text, and now we have this enumeration here, and then let's just keep on going through here until everything looks alright. So PNG file. Is this also our bootlegged enum? Yeah, it's a bootlegged enum for PNG file, so we're going to take this one. We're going to paste it there. So now that's fixed. And this says any text right here. Any text, bootlegged enum. So we're going to take any text. Okay, so now that's fixed. And then we gotta go through here, any text equals, so this any text. So it was already hard enough to work with this before, because I had to make this crazy, right, because I'm so nested here that I had to, like, make this really shorthand thing for the different enumerations. But now that these macros are a little bit shorter, so maybe I can just say that define any text as this, and it'll fit. Oh, it will fit, so we can just get rid of that, any text PNG file, any text and PNG file. Then we can get rid of this disaster of a macro right here, where we're just kind of using the preprocessor to glue stuff together. Right, so we can remove that. And then we can get rid of this commentary now, because we don't have that disastrous macro, so that's good. So I can remove this as well. So any text and PNG file. With an IDE, you could rename the variable and it would change all the occurrences. Yes, you are correct. But I am paranoid when I do that. Like anytime you leverage... So when you have the leverage to make changes like that, that's great. But then you also have the leverage to make huge disasters. So I like to make sure that every single variable that I rename actually looks correct. That I haven't done anything stupid. So payload enumeration. So this thing here needs to change, right? So this is going to be any text, and this one's going to be PNG file. Any text matches any text. PNG file matches PNG file. So also the hope is that when I refactor, I will so when you refactor things, you have the potential to break things, right? Especially when you leverage auto-replacing like that. So my hope is that if I replace like this, that if I'm careful about it, rather than having the potential to break things, hopefully there's potential to fix things, because I'm giving everything like one more look over. That's my hope. That's my justification for my crazy ways. But the real reason is just that I'm not using an IDE, right? That's the real reason, right? But I can make up all my nice little justifications so that I can live in my world and not think that I'm being completely stupid about the way I'm going about things. So any text right here, that's been changed. So PNG file, this is PNG file, PT PNG file. So let's like put a little, let's color this right here like this and just give it like a really obnoxious color. And then let's kind of flip through everything, and once we see that big block of color again, we'll be like, oh, we're done. Any text, any text. Yep, so is this any text? It says naked text to PNG file, so that means that so the payload is a PNG file. Yeah, the payload out is a PNG file, and that is why... that actually looks kind of suspicious. That says any text. I don't think that's right. PNG file, the naked text. This would be any text. So it says text. So this says text right here. This says text right here, which is valid, right? The output payload is called naked text, right? This naked text object. And the naked text object right here, it's flagged as having the type naked text, right? Now this thing is PNG file, right? The payload is called a PNG file, right? It's the inverse, naked text to PNG file. And if we look at the PNG file, the PNG file is The function that reads a PNG file or a TXT file is in a different section, in like a file access section. This is the this is actually the algorithm functions. These are the raw algorithms, not any of the file access. So when I'm saying PNG file, when file is the actual bytes. Yeah, so PNG file is a file on disk, the actual bytes. So PNG file, this text type equals that. That's correct. So this thing, C99 text, that's any text type. C99 text to PNG file. PNG file is PNG file. So that looks good. Nothing found. Any text. I swear I saw something that didn't look right. So let's kind of scroll through here again. I swear I was looking at something that didn't look right. Bin txt PNG file. Well, this doesn't look right. Command PNG file to naked text. And oh, naked text.bin txt right here. So then what the hell is this bin txt over here? Load file if it exists. Oh yeah, we use okay, I see, because I use bin txt in other places, so that's actually correct. Because this bin txt is not the same bin txt as the one further down, right? Because I'm loading this thing here. I don't know if this is what you're talking about. This is where I'm actually loading a file from disk, and the type of this is indeed a PNG file, right? Well, then later on, instead of having a PNG file, because we're going to convert to text, so that's why that's any text. So that makes sense. So any text, PNG file. C99 text, PNG file, okay, output parameters. I would say that this isn't finished yet. So this function isn't finished. Whatever, let's just give it a run. Let's just give it a run and see what happens here. Okay, 11:30, I'm really going out to jump on the trampoline, because I'm almost out of room here. Does not allow extra great. So somewhere my bracket balancing went to hell. It's on 11:10, so in my enum maybe? Oh, this thing. I have a habit of doing that, so that should probably fix it. Unknown type name, yeah, so I thought that maybe... oh, this thing needs to be called... Well, first of all, let's just call it PT, like we're calling it in other code, and then let's use enum. Right, so PT is enum, blah, 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 and whenever we use payload type, bam, we'll change that. And, oh boy. I'm gonna guess... So that's a disaster. This already exists. But however, this enum... So this enum, error AAC 2020 PHEXDUM, enum, any text. I can't find that anywhere. It's like, it's saying that this doesn't exist. Oh, because it's in this macro. So I still have some, like, weird macro that I missed. God damn it. Okay, here we go. So I used another weird macro here. So this is why I try not to, I do try not to use weird-ass macros like these, because then it's hard to find things. Right, because I split up the, I try to use macros only for direct replacements. Oh, no, it's okay, I mean, you have to experiment with different ways of writing code in order to find, the best way to do something, you know what I mean? So, like, I've experimented with many batshit crazy ways to write code, so you gotta, like, experiment with things, and you really don't know what's gonna be productive until you actually experiment with it. And the other thing is that, that if my workflow wasn't completely insane, then this could possibly be an effective way to do things, right? Where, like, oh, look, it's all well documented right here, kind of a thing, you know, where it's all in here. But the thing is, because I think the reason I don't use enums, well, besides the fact that I don't get a guarantee of this 0 is actually int32, the other reason I don't use enums, I believe, was because of the fact that, well, this is not directly connected to this anywhere, right? I have to write these things here, so I don't get any namespace advantage. And usually when I'm using enums, the whole reason I like enums is to have that, like, namespacing aspect. And you don't really get that in C. So I believe that's one of the reasons. But anyways, so we're gonna strip this out. So this PE macro nonsense, because now I believe we have enough room to just write the macros all the way. So we can say that any text, we can take any text right here. Any text is going to be this guy, and then PNG file is going to be this guy. So, in one aspect, even though we could say productivity slowed down, but hey, we have, yeah, it's mainly to avoid magic values and mixing them. Yeah, I got you. Like if you don't have a guarantee on what the type of your enum is, then you can't safely mix and match integers and enums for some crazy reason. So the enum is probably there to prevent you from doing stupid stuff, and that's why you don't get a guarantee on the type of the enumeration. But then it's just very hard when I'm doing things like, but it makes it harder on me when I'm doing things like, I don't know, doing things I shouldn't do, like using an enum without a header file, and trying to figure out exactly what the value is, and I'm like, should I use it int32 or unsigned? I don't know. And yeah, it can be used as documentation. Yeah, you're correct. Yeah, that this is that if we want to think about this, that yeah, right here, the names in here can actually be used as documentation, so that we know what the hell we're talking about, right? So yes, you are correct that that is the thing. Having code that kind of documents itself is a good idea. And the time is 3 hours, 46 minutes, and let's just say 47 minutes, because we're about to roll over there. But yeah, I get the idea that, yeah, you can use that as documentation there. And bitfield, yeah, bitfield flags, yeah, like in, Vulkan has, like, a lot of bit flags, like, crazy amount of bit flags, bitfield flags. Yeah, once you start to get that crazy, then, yeah, it starts to make a lot of sense. So I don't know what else I'm missing. Let's just try to clear this and see if we can get this to compile. Okay, so now the question is, did we totally destroy anything, or can we get this to say, can we get this to do the thing it was doing before? So PHEXDUM .exe, and then we'll do like PNG to naked array, and we'll do logo.png, right? So we'll try that, make sure that still works. Looks like that's still working, so this file should say it's been reloaded. We'll reload it. And yep, still has data in it. Still has the magic number up here, so that looks good. Okay, so now let's try the opposite. So let's clear this. And let's close this file, because it's probably going to get tampered with. And we're going to just change, we're going to invert it. So we're going to say naked to the inverse, right? So, hold on. We're going to take the naked array that we made, so we're going to take this, and we're going to convert it back into a PNG file on disk, right? So we're going to turn this into a PNG file. So, yep, exactly, yeah. So I don't actually need this part to... I don't actually need this part to write the tools that I want to write for the engine, but it's like, if I'm gonna write this hex dumping tool, there's a part of me that's like, if I'm writing a function that converts something to something, I want the inverse or the opposite function. Like, I get that, oh, maybe I'll never use that inverse function, so I'm violating the Yagni principle of you aren't gonna need it, but it's like, come on, I can't just write a conversion function that goes one way and then not do the one that goes the other way. And also, being able to do it back and forth also makes it easy to test, right? Because you can just say convert back and forth and make sure that you have the same thing you started with, right? So it's like, maybe I shouldn't be doing this, but I'm kind of committed to making the full utility. So let's say it's going to be called, what is it called, that file called? It's called like PNG or TXT. Horrible file name. It's just like the default file name. Yeah, so we're going to go 1, 2, 3, and actually, let's not quote that. I don't know how quotes work, but let's not quote it, because I know how I am parsing my arguments, and I think the quotes just get stripped off when it gets passed into the function, but I want to be careful here. So let's try that and see what happens, and I have no clue where it's going to be saved. Assertion failed. That's right. So this was the assertion we were trying to fix earlier. But I need to go jump on the trampoline for just 100 jumps, which should be it should be less than 20 minutes, but I'm going to say 20-minute break just in case, because yeah, I'm going to say 20-minute break just in case, because I don't know. I don't know how long it's going to take. And also, yeah, just in case. So make sure I have enough time to jump on the trampoline. So red timer. So I don't know what you're doing. You said you were already tired or whatnot. Yeah, oh, I found one. Here, let me find one for you. Hold on, before I put the break timer on. Well, I don't know. It wasn't... I don't really... I just found one, but I'm not going to say that it's my type. Because... I have a very specific type, and... yeah, I have a very specific body type that I like, and it includes, yeah, not really a fan of people who are, what do you call it? How do you say this politically correct? Surgically enhanced? Yes. But, yeah, so now anytime I'm, like, running around on Twitch and I find one, I'm like, I put it in my little shortcut list. But yeah, I'm surprised. I'm trying to figure it out. Here's my thought. I'm thinking that I don't understand I thought there's like cam girls for this kind of stuff, but then I guess there's like teenagers that, you know, don't have credit cards, and so they can't use adult cam sites, so they're on Twitch. That's my guess. That's my guess. That's just my hypothesis. But yeah, I'll be right back. I'm gonna put on the break screen. Hey, if I was beautiful, I would be a Twitch thought.
solution? Well, we're off the gold standard, so let's just print more money. And print they did. That printed money was used to buy foreign currency, that foreign currency was used to pay off their war reparations, and soon Germany was buying foreign currency at any price because why not? All they had to do was print more money. So in just a little over a year later, the German mark was already practically worthless. A $50,000 bill turned into a $500,000 bill, to a $5 million bill, to a $50 million bill, to $500 million, to $5 billion, to $50 billion, to $500 billion, to $5 trillion, to a $50 trillion bill. Bills that were worth more of its weight as wood fire than as a medium of exchange. A loaf of bread that cost 160 marks by the end of 1922 skyrocketed to 200 billion marks just a year later. Although Germany was the most infamous case of hyperinflation, it is far from the worst. This episode is brought to you by Trends. Learn about thousands of great business ideas that you can take advantage of long before you read about them in the Wall Street Journal. I personally enjoyed reading about the massive growth around apps popping up on Slack's platform. Who would have thought that Slack apps would grow into a $300 million market? Stay tuned to the end to learn more, or feel free to discover your next big idea right now by going to trends.co/JakeTran. Try out Trends for an entire week, all for just $1. Again, that's trends.co/JakeTran. The link is also in the video description below. Hungary. August 1945 to July 1946. Highest monthly rate of inflation, 4.19 times 10 to the 16th power, or this giant number. Equivalent daily inflation rate, 207%. Time required for prices to double, 15 hours. After World War II, like many countries, Hungary was left in shambles. Their industries were crippled, and what remained of their assets were seized by both sides of the war. So the amount of goods produced went down, but the amount of money in circulation stayed the same. So, inflation. But instead of trying to reduce the inflation by reducing the amount of money in circulation, which could have made the already dead economy worse, Hungary took a different approach. The government intentionally caused inflation by printing literally as much money as they could. What started out as 25 billion penge in July 1945 grew to 1.6 trillion penge 6 months later. Then just 4 months after that, the money supply grew to 65 quadrillion, which is a million billion. Then just another 2 months after that, to 47 septillion. That's 47 trillion. To make this a little bit more comprehensible, something that cost 379 penge in September 1945 went up to a trillion 10 months later. At one point, the government had to stop collecting taxes, because if they were late by just 1 day, it would have wiped out the value of the taxes the government collected. Needless to say, this would go down in history as the worst case of hyperinflation ever. Yugoslavia, April 1992 to January 1994. Highest monthly inflation rate, 313 million %. Equivalent daily inflation rate, 64.6%. Time required for prices to double, 1.4 days. Yugoslavia was a nation born in the wake of World War II that was made up of these modern-day countries. During the early days of the breakup of these nation-states in the early 1990s, the second worst case of hyperinflation occurred. Far worse than the Weimar Republic, yet it seems to have slipped under the public's consciousness. At its peak in January 1994, the official monthly inflation rate was 313 million %, or 4 times higher than the Weimar Republic. And the results were devastating. People's income dropped more than 50%, they couldn't afford food if there was any to be bought, bread lines for and gas stations were closed, foreign exchange black markets emerged. To put it into perspective, imagine the money you have in your bank account right now, then imagine moving the decimal point 22 places to the left. Then imagine trying to buy something. Then imagine trying to survive through this for 2 years straight, from the start of 2020 to the end of 2021, for example. Zimbabwe, March 2007 to November 2008. Highest monthly inflation rate, 79.6 billion %. Equivalent daily inflation rate, 98%. Time required for prices to double, 24.7 hours. After Zimbabwe gained independence from the United Kingdom in 1980, this opened up a whole new profession: politicians. Politicians whose first priority has always been to secure those votes, to secure their seat in power. And how do you secure that public support as a politician who has control over the government spending? Offer free stuff. So offer free stuff they did, which created a spending problem for their government. Add on top of that a ton of other stuff like
Okay, let's see. Where am I? So this assertion that's failing over here. I need to figure out what the hell is going on with that. So this assertion was actually added because this variable became pointless after using this payload object. And so I decided, hey, let's use this as a redundancy. And so the idea is that if a payload exists, then the text should be freeable. And if a payload does not exist, then the text should not be freeable. So these should both either evaluate to 0 or they should both evaluate to 1. And this check doesn't seem to be holding up. So we're going to change it from an assertion to an error using like my error function so that we can print off more information here and see what's going on. So error, and we're just going to say payload and freeable flags disagree, right? So that's what's going on. And now the question is, let's print this stuff out and see what's going on. So printf payload has %d \n payload has. Then also print off the text out freeable. So unfortunately, that's kind of a big variable. So let's just define p for printf, or pf maybe. I think pf will be enough to get all the room we need. And then down here, we're going to undef pf. And yeah, that looks good. Okay, so we're just going to try to compile like that and see what happens. Something, something, god damn it. Okay. So 2251. Oh, do I have what do you mean no effect? Oh. Yes. It's not just enough to think it. Yeah, you have to define it to something, otherwise. Okay. So payload has is 0, text out is freeable. So that is a valid state. So I guess I don't know how C evaluates, like if 0 equals 0. Hold on. Did I just do my assertion backwards? This situation is okay. Okay. Both are true, or both are false. Right, so that's okay. Okay, so there we go. So now, let's try that again. And we're going to do PNG to naked text array. We're going to do... God, what did I call it? I keep on forgetting what I called it. PNG or TXT. PNG or 1, 2, 3. I don't understand what happened there, but now we have something. It's definitely not printing what I want to print. However, let's see what this looks like. So that's not what I want. Oh, wait, hold on here. Oh. It took the bytes of... Hey. So I'm over here. Yep, still doing that. I just got back, about... I don't know, 5 minutes ago. So anyways, I'm gonna try to PNG to... This is wrong. PNG to... Okay, first let's do this. Okay, now we have this. Okay, now I want to go the other way. So, we're gonna say... I'm going to take the naked array, convert it back to PNG, and we're just going to say we need PNG or TXT as the input file, and hopefully I have another output file, otherwise this is going to not go over very well. So payload has is set to 1, but then text out freeable is set to 0. So that's the problem. These flags are disagreeing with each other. I absolutely know that there should be a payload, so I feel like that is correct. Now, text out freeable not being set, that's a problem. So let's kind of figure out, well, where is text out freeable being set? And why is it not being set where I think it should be being set? So, oh, right, because the text isn't freeable. If it's a PNG file, the output text is will save to disk, right? That's not, yeah, so payload. So payload is just my thing that should be a, it could better be a union, right? So here's the payload type right here. Here, let me clear some coloring here. So let's zoom in here. So this is the payload type, and inside this struct, this payload struct, it contains this flag here, the payload type, and that's just a tag, right? It's just a tag to tell me, do I want to use bytes representing a PNG binary file, or do I want any text, right? So it switches between any text and PNG file. And then the length, this array length applies to either PNG file or any text. So at any given time, this is basically a union, but I wrote it as a struct, right? So this value bin txt, this payload type, determines whether the PNG file memory is here, or if the any text memory here is here. And the reason that this exists is because while I was writing this a few days ago, I'm like, okay, I have this command. It's going to take a PNG file and it's going to convert it to C99 text. And so this is the const char to get the file path. And then this payload type is whatever I need to return. And originally I was just going to return a byte array or a char array. Now the problem with just returning a byte array or a char array as a output parameter of these is, well, we want all of these to have the same signature, like it's kind of like an interface, and for them to all have the signature, that would mean that we would have to return a we'd have to return like all of them would have to return like a void pointer, right? And that void pointer could either point to a char array or a U08 array, right? A byte array or a char array. And that's already kind of dirty, because I don't know if that would technically violate strict aliasing rules, but it's still kind of ucky. And then the other thing was, okay, well, when I'm returning the char array, it's really easy to print it out, right, into a file because the char array is null terminated. But, okay, well, how am I going to do it when we have just a file that's a series of bytes that makes up some type of binary file? That's not null terminated. So how am I gonna get the length out of it? So I thought, oh crap, I don't really know the length. So payload is just an object. If we really wanted to simplify it, payload is just an array and a length stored in a struct. So payload array data. So payload is basically this. Payload is array data and array length, right? That's all payload is. It would be okay, but the struct thing is more convenient, yeah. And but yeah, so it's very important here that this that all these functions have the exact same signature, because the way we're gonna run these functions is we access them through like a big jump table. So we look up the string we look up the command in a table, and that command gives us a certain number into a jump table. And since it's a jump table, since I'm using a jump table to get these different commands, I need to make sure that all the commands have the exact same format. But that's nice. That is kind of nice, because now I have a way to pretty I think this is a pretty decent way to do interfaces in C, right? You say, here's a cluster of all these functions that we're going to forward declare right here, and we're just going to give them all the same exact signature. And then to further, prototype is the formal name. Okay, yeah. So yes, prototype, not signature. Which is, I still find prototype very weird, because when I think prototype, I think like, I don't know. Yes, but prototype is the correct term, yeah. Which just seems really weird, because I'm really used to calling this a function signature, but then a function signature doesn't include something here. I forgot what it doesn't include. Like, a function signature is like, hold on, let's go look that up for a second, because there is like a specific difference where a function signature has like less in it than a prototype, but I forget what the difference is. Prototype versus signature. What's the difference between function declaration, function prototype, and function signature? Function prototype is used during function declaration. It must match the function definition in name, return type, and argument order and types. For example, bool, int. Function signature, overload resolution by the compiler. It only uses the argument order and types, and not the return type. Okay, got you. Yep. Okay, yeah, that's what I thought. Okay, yeah. So, got ya. Yeah, when I say function signature, I usually mean prototype, but it looks here, I mean, there's other people who probably answer it differently, but it looks like function signature does not include return type. Right, because they're saying that function signature is used for, like, overloading, right, like where you have, like, two functions of the exact same name, and you want to know which one to call, you look at the function signature, right? So if you have like square root, and you have a square root that takes a float, and then you have another square root that takes an int, the signature doesn't know anything about the return type. It just needs to know what the formal parameters are. So let me make a note of that for a second. That's like trivia that I don't know if it'll ever come in use, but function signature versus function prototype. Function prototype versus function signature. Jeez, this is long. Return type. So, that's my understanding. That, yeah, prototype has more information. Yeah, now I'm starting to put video IDs in my shortcut scripts, so this is getting crazy. 4 hours, 28 minutes, and let's say 29 minutes, because it's about to roll over. And what's the date? The date is 2021-0205. Okay. So I will keep that for... That doesn't seem right. The date or my definition? We could go on Stack Overflow or something and keep on looking it up. Or you could, signature does not include return type. Okay, so you're saying signature does not include return type. Okay, now I have to go on the internet and look more stuff up now. Can we find a definitive source? Because my understanding is that signature, signature not equal to prototype. That's my understanding. Is that signature is not equal to prototype, but that sometimes people casually use My understanding is that signature is not equal to prototype, and sometimes people casually throw around signature when they mean prototype. That's my understanding. Signature versus prototype. Oh, wait, did I get that wrong? Did I do that wrong? Oh, no. Let me read your comment again. Signature does not include return type. Oh, wait, that's what I wrote. Signature does not include return type. There is a deprecated implicit int from KNRC. Yeah, the whole, like, unsigned, whatever fuck. This thing? Like, when people do that kind of stuff? Or signed. Like that kind of thing? Or am I missing something else? I know there's some really crazy, like, C code where, you declare all the inputs outside of the like in the old KNR, it's like R. Yes, but far from that, you have to declare function return type. You have to declare function return type. Function prototype. Wait, hold on. Let's go to Wikipedia. Function prototype. Is there the word signature in here, though? Okay, so there's the word. Okay, function prototype or function interface is a declaration of a function that specifies the function's name and type signature. Okay. So type signature and computer type signature or type annotation defines the inputs and outputs for a function. In computer science, a type signature or type annotation defines the inputs and outputs for a function, subroutine, or method. A type signature includes the number, types, and order of arguments contained by a function. A type signature is used during overloading. Okay. Okay, so you're saying okay, so this one does say that it includes the output type. So are you saying something like this, like int arg 1, int arg 2, and then int. Are you saying something like that? Where it's like, this one's a prototype because it has the names, and this one's a signature? Or are you saying that they're just completely synonymous? I went over that in a forum, but it's in Portuguese. They are both prototypes. Okay, fair enough. Let me take that. They're both prototypes. Alright. We will revisit this at another date. Okay. Let me close this. Let me put this over on the other side. Or wherever the hell it belongs. Right over here. And... so yeah, so when I'm looking at my assertion is just wrong because this thing that says will save to disk, this is not freeable. So sometimes the text, so where I'm using text out freeable, this is the only place I'm setting it, I believe. Or actually, yeah, so I'm only setting it there, and that's because I need to know when I can free, I need to avoid a double free, though. No, that'll be okay. Or will it be? So, I'm afraid here that this is going to do a double free. Because I say text out is freeable, and I say payload.anytext. And I set it equal to this. And if text out is freeable... so we know this isn't this assertion is bogus. So that's something to keep in mind. And let me put the chat back up here. I kind of lost track of here. So I want to be very careful that I don't double free any text. Double free is okay if you zero out the pointer. Got you, because if you try to free... got you, so if you try to free it, but it's a null pointer, I got you. Okay, okay, well, if that's the case, then, then we'll do that. Okay, okay. So, I can't even figure out where I was. Ah, crap. My throat is all getting... Ugh. Okay, so... okay, so I'll remember... okay, I need to get some water, because I can't, my throat's like, I can't talk. I'm gonna go upstairs and get some water really quick, and then I'll be right back. I'm just gonna walk upstairs, and I'll be, like, right back. I'm not even gonna set a timer, I'll just be right back. Okay. Let me get my headphones back on here. Okay, double free is okay as long as I zero out the pointer. Got it. So I am really confused as to... I thought I used this in some places, and it's not being used where I thought it would be used. Let's just go look for the word free and figure out where the hell I'm freeing stuff here. Output text before freeing memory. Makes sense. You don't really want to try to print it if it's not freed. And text out when freeable is pointed to... Okay, text out when freeable is pointed to memory in our payload object. Text out when freeable is pointed to memory in our payload object, so don't free text out, just free the payload memory. Otherwise, we'll get a double free. Let me make a note of this. So it looks like this code is going to be okay the way it's been written. I just need to change that assertion, it'll be fine. So I'll free... yeah, so as long as if there's a payload, then I'm going to free the any text in it. Okay, okay, I see. So we're actually good here, but I will make a note of what you said, so I'll note for next time that I can just go free, and then I can set it to 0, and we'll be fine. So time, and 0440, 04. Okay, so right here, where we're freeing this, yeah, it would be good practice to... zero this out, right? So it would be payload.anyText equals, right, zero that out. And same thing here. Here it would probably be good practice to also zero this out as well. Alright, so better seg faults aren't nice, but it's worse to be reading from memory that shouldn't even exist. But generally something not well designed if that could happen. Yeah, I got yeah. You want your code to have you know how you're doing things as branchless as possible, right? You want to eliminate the number of code execution paths and get everything to kind of like flow with minimal branching, right? Because the more branching you have, the more bad, unpredictable things that can happen. Which... that was the whole point of like having a jump table and having a common interface, was to have something that kind of flows nicely. But I think that in a lot of ways, a lot of this code is a disaster. But it's one of those things where I don't know, sometimes the code I write is kind of hit or miss, where I'm like, sometimes I like what I see, and other times I'm like, this sucks, but let's just finish it. Finish it, test it, make sure it works, kind of a thing, right? So you write sometimes you hate what you write because it's a big cluster mess with the F, capital F, and so you finish it, you write your test for it to make sure it works. You hate it, but it works properly, right? So as long as you can get the interface, like when your code just looks horrible and it's confusing or whatever, you write your test, you make sure your code works, and you make sure it has an interface that you like. And as long as it has an interface you like and the tests pass, then that's kind of like good enough, right? It's like good enough, move on, get to something else, kind of a thing. And that's kind of where I am, where I'm like, so let's compile. Actually, no, I haven't even figured out that assert yet. I still haven't fixed that assert. So I don't even know where that was again, because I lost my, well actually no, Freeable text, right? So, so text out Freeable. Yeah, this assertion here. So, what I'm going to do is I'm going to make another assertion. And it's going to be kind of like this, but slightly different. I'm going to duplicate this line. I'm going to put this over here. I'm going to do that. And then, actually, no, I'll put this over here like that. Like that. And then I'll put a not equal. And then I'll just put a little comment here. You are wrong. Okay, there we go. So, I just want to make a note here that, I'm wrong about this. And, yeah, it is a pointless assertion, but I don't care. I do kind of like to keep track of the things I don't do as well as the things I do, which is kind of like a... And let's just put 42, because we want to be cool, even though Hitchhiker's Guide to the Galaxy was not that good of a movie, but maybe it's a better book. I don't know. Haven't read it. But yeah, so this was just a pointless assertion, right? Because there is a scenario where I have a payload, but the text is not freeable. So I thought this was not the case, but yeah, so just put that in there. Good enough for me. So let's do the compile. And does it not like me because I did something that is pointless? No, it says... Hold on, did I miss something? It's missing... Oh, yes. I got ya. There we go. Because I forget about operands sometimes, because it's like, I remember to format it the way I like to format it, and then I just kind of forget that, oh yeah, it's this or that, right? So the idea is that equal to or not equal to, right? So it's a pointless comparison. Okay, so now that we have this, let's see if we have this data. Let's reload it, sure. Okay, so, right, because when we compile, we run the code automatically, but it gets ran with 0 arguments, because that's the way our build script works. So now we have to go PHEXDUM.exe. We're going to do PNG to naked array, and then we're going to take a logo. Sure, why not try to quote it just to see what happens, because I don't know. And there, we got some stuff. Let's reload this. Nice. Okay. So now let's try the opposite now. So let's go up here, and let's say naked text convert to PNG, and then we'll say, well, we need PNG or TXT. So PNG or TXT dot underscore underscore underscore. And we'll save to disk. Okay, I hope you're right. Do I want to reload this? Sure, yes. Okay, well, that looks like a PNG file. So what we're going to do here is we're just going to close this without saving it, because we don't want to corrupt it. And then we're just going to, like, rename this to, like, PNG, right? We're just going to go .png. Yep, and then we're just going to try to open it and see if it is intact. Oh, it's intact. Nice. So we've been able to go one way and then the other way. So that's pretty cool. Whereas the kids would say dope. Or at least, well, I don't know what kids say anymore. Maybe they say something else nowadays. And I was never into, I don't know, I was never into slang, like, what do some people say? Dope, sick, legit. What else do they say? I don't know. I've never been, like, one to like talking in slang. Even if the people around me are talking in slang. Which probably is, like, that's probably maladaptive. Okay. So, I don't know. That's kind of all I wanted to do for now. Because the next part is just, the next part I want to do later. Like, maybe, I don't know. I'll probably try to do it tomorrow sometime. Is, I want to take, like, int32, some... Yeah, I mean, I think it is cringe kid talk, yeah. I mean, it's like... It's like, like, I hear it, like... I don't know, like, there's definitely, like, a certain type of, like... Like, when people talk like that, my immediate assumption is you're one of those kids that probably didn't get good grades in school. That's my only stereotype. Basically, if you talk like that, that's the only stereotype that comes to mind. Yeah. But I mean, not to say that I don't associate with those kind of people, but not like, what do you call it? I have a very limited amount of free time, so like when I do associate with people, like when I willingly associate with people, it has to be to do something useful, if that makes sense. So like back in the day, once upon a time, there was this thing, they called them clubs, and you'd, like, go to them, and you'd be able to, like, listen to music and dance and party and drink alcohol and that kind of stuff. So once upon a time, there was things called clubs, and sometimes people will meet you, and they'll think you're cool, and they'll want to hang out with you. And then you gotta break it to them and say, yeah, I only really hang out with other programmers because, like, if I'm hanging out outside of a club and not, like, partying, then I actually want to be doing something useful. And yeah, so usually I just say that I only really hang out with other programmers outside of the club, because it's like, I just want to do something useful, man. If I don't want to do something useful, then I'm going to be at the club, but if I'm being useful, then, you know, time is limited, right? But yeah, so the next thing we want to do is we just want to be able to take the same kind of stuff, right? And we want to just be able to, like, do this, right? We just want to be able to parse back and forth, but we want to have this kind of thing going on here, right? So we want to take this and turn it into a PNG file. Or we want to take a PNG file and turn it into this. And now the thing with that is, I gotta think about why I want to do this. So before I even code this, I need a day to think about it, because I think that I don't know if there's any utility in this. Yes, yes, okay, we'll do some unit testing. In fact, we could probably do some unit testing right now. Since, yeah, let's try to test what we already wrote. How about that? So, let's go create, like, a unit test section down here. Okay. I think you've seen my crazy unit testing before, right? Like, how I write, like, little tables for things and whatnot. So, let's say, so, I do want to make sure that the name that I use for my test is kind of the same kind of format that I'm using for the main library, so it's easier to integrate into the main library. So there should be, so in here, let's look at another library in here. and just see what the names that I'm using here are for. So let's like take one of the newer libraries, P5D, blah blah blah. Look at the functions. Actually, I put it in its own unit testing code, didn't I? So conversion functions, but where's that being called from? So this is a unit. This is definitely a unit test function. Unit test code something something. Got it. And that's being called from in here. And okay, double namespace unit test code private. Okay, so UTC stands for unit test code. And unit test code private. Okay, so I just call it. Do I just really just call it unit test? Is that what I do? I mean that's fine if that's what I want to call it. I mean that's that is very self-descriptive. So okay, yeah, sure, that's what we'll do. So we're just gonna say, you know, AAC 2020, right? And then we're gonna say unit test, and then we're gonna say void, and then this is also going. Actually, no, this is going to be U32. Shouldn't this be U32? Hold on, let me look at this again. Underscore unit test. I need to look at one of my other things, because I'm going to guess this unit test code is like, yeah, this unit test code I think is like, broken up a little bit differently than I usually do it. So let me look at, that's not quite how I usually break it up. So let's look at, another system for a second, because I'm pretty sure that the unit test function usually is called from somewhere, and it has a very specific signature that I don't actually use, but it's there. So, so helper functions generic, helper functions conversion, just a whole bunch of helper functions, blah blah blah, conversions. Pixel bit packing. Unit test code is usually always at the bottom, because it's the last thing I want to look at after I'm completely done. So when we're looking through all these sections, default tile pattern thingy, keyboard handler, subsystem backup code, viewport helper function. Whoa, geez, there's just a lot in here. Init or update. I don't know what that's about, but it's not test code yet. Maybe I should just go into the unit test code. Unit test section. Okay, and PAINT5D unit test. Yeah, so this is how I usually do it, right? So U32. So yeah, this is how I usually do this. PAINT5D. Okay, yeah, I'm just making sure that I conform to some type of standard way of doing this. So it takes a U32 and it returns a U32. So the idea for that is that eventually, right now I'm not actually using the inputs for anything, but the idea is that, you know, eventually I may want to return some type of flag value from these, but I say that, but it's seeming more and more likely that I'm never ever going to ever use these inputs and outputs. So now it's like, why am I doing it? But the thing is it's like, this is the way I've been writing the prototypes for all of the other tests, so I want to keep it kind of uniform, right? Like, I want to be as uniform as possible. So even though my code is batshit crazy, I want to be uniform in the way I write my code. So, so we'll define U32 up here, and then we'll undef it up down here. Undef U32. And within this function, let's say we need, let's think about what kind of data set we're gonna need. Oh, that's why I need. So how are we gonna do this without file system access, or are we going to? Should a test read and write to file? I mean, why not? I mean, it doesn't seem like a problem. Okay, yeah, sure. So let's so what we really need is, I have some other features for those two functions that I need, because I think that the data expected something something, yeah. So we could just here, you know what we'll do? We'll keep it, yeah, let's not try to overthink this. Let's yeah, let's yeah, let's not overthink it. Let's do load PNG, file name, data size. Yeah, so let's do assert load PNG, file name, and data. Assert size of data expected, data size. Assert mem copy, data expected. Okay, yeah. So here's what I'm thinking. So let's one man spam. Yeah. So let's take, where are you? So let's take, where's our other one? So PNG to naked array, right? This is text right here, with the logo.png. Let's take that, and let's just use this, right? Let's just roll with that, right? Let's just, this is our test, right? It would be nice to format it a little bit differently, right? But really, this is our test code, right? Cut that, right? That's the PNG, right? And we can just throw that in there. And the cool thing about that is, if we do that, then we have my company logo kind of like embedded, will end up embedded into the engine, right? So I'm trying to like have ways to like encode things into the source code, so that I can, if somebody uses my engine, I can decompile or inspect their binary, and I can tell that they're using my engine because there's certain things that give it away. For example, if there's a PNG file with my logo encoded somewhere in an array, that's kind of a dead giveaway, right? So yeah, so we'll say, I'm going to say like U32 Vectin logo PNG binary as uint32 array. So we'll make a big, so even though I do really have shorthand names most of the time, when it's a so in natural language, words that you use quite often are very short, and then words you use very infrequently are long. And I try to keep the same idea in my code, where if it's something that I don't use that often, like a variable name I don't use that often, I make it longer. Or a long variable name like this that does not have a weird format, right? It doesn't have that format where everything's grouped in clusters of 3. If that just means that it's a variable I haven't put a lot of thought into, or it's like a one-off variable, right? So I don't always normalize all of my variable names to like that weird format that I kind of use, but I do it kind of like when I what do you call it? I do it a lot, but not all the time. Now, I should probably try to streamline this somehow. Hold on. So we need to take 1, 2, 3. So we gotta go 1, 2, 3. So we gotta go bam, 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 and then 1, 2, 3, and then bam, bam, Okay, this could take forever doing it this way. I know I had... What is this nonsense? Hold on. How is that? Did I accidentally delete something, or... 1, 2, 3, it's missing a 0, or what's going... That's not good, that's not good. How the hell did that... Did I delete that? Did I do that? Hold on. Yes, I did do that. Okay, so this is going to be very error-prone. Record a macro? Yeah, so... So, yeah, there should be a... I think that we should just edit the... Remember how we said that eventually we would edit the printout to change how it prints out? I think we should just add that feature into the library itself. I need to take a break, though. So... I'll be back in, like, 15. Or actually 16, because powers of 2. Yeah, but we could put that into the library, right? Rather than try to make a macro, we could make that a function of the library to pretty print that. So, I'll be back.
government seizing farms from white farmers and giving it to black farmers that didn't know how to farm, which created a food shortage.
The situation was made worse by costly participation in the Congo War in 1998 and sanctions against Robert Mugabe's government in 2002.
The government blames its financial problems on sanctions imposed by the EU and US during Mugabe's reign.
The banking sector collapsing and the money printer going burr, and you have the perfect storm to nurture some hyperinflation. The general rule of thumb is that hyperinflation is when the monthly inflation rate is above 50%. And since 1998, Zimbabwe has been hovering around a 50% annual inflation rate. Mixed in Zimbabwe's central bank continuing to tinker with the economy to try to slow down inflation, and by March 2007, the country was experiencing full-blown hyperinflation, with again it peaking around 79.6 billion% a month.
Prices in shops would go up several times a day, water and power cuts happened often, and there were queues at banks, petrol stations, and severe shortages of food in supermarkets.
A problem they're still struggling on and off with to this day.
This year, inflation is hovering at around 300%. That was the latest figure before Zimbabwe's finance minister put a moratorium on publishing numbers until next year.
Venezuela, 2013 to the day. A situation caused by both political and economic reasons that range from the government controlling parts of the economy, shortages of food, electricity, medicine, riots and political instability that stem from that, oil revenue tanking even though they have some of the largest oil reserves on the planet.
Gasoline has been in short supply there for years. The shortage has now reached unsustainable levels and is hitting the capital Caracas in the middle of a pandemic.
Economic sanctions from the US and more, with hyperinflation starting at modest levels in 2013 to peaking at around 1.6 million% in 2018, with the Venezuelan central bank estimating that the currency was inflated by 53.8 million% between 2006 and April 2019.
There's no coffee, no flour, no oil, no butter, no cornflakes. There are a lot of food products missing that aren't luxuries, just normal food.
They were able to tame the hyperinflation back down to better levels in the low thousands of percents in recent years, but that still means that for the average everyday shopper on the streets, prices for goods are doubling every few weeks. One woman said, "Everything is rising so quickly that what I deposit in my account doesn't buy anything. All we can do is eat less and stretch what we have." Which brings us to today, in the West. The United States, January 6, 2020 to January 4, 2021. Coming straight from the Fed, we started this period with around $4 trillion in the system. 1 year later, that number is at $6.7 trillion. Meaning that over 40% of all US dollars were printed in just the last 12 months.
Well, we've had an incredible surge in government spending. A lot of it related, of course, to COVID-19 and to the ordered, economic shutdown and the fact that a lot of people were no longer out there earning money. And so the government looked to replace what people were no longer earning by printing money, which is what they did. They had all this government spending, but there were no additional tax hikes to cover the cost, nor did the government try to prioritize any of the spending. It didn't say, well, maybe we should spend less on the military so we have more to spend on fighting the pandemic, right? They didn't budget their resources. They just said, well, we're just going to spend more money on the pandemic, but we're not going to spend less on anything else, and we're not going to raise anybody's taxes to pay for it. So where'd all the government spending come from? It doesn't come from thin air. The money has to come from somewhere. And if they're not going to make room in the budget by cutting spending, if they're not going to increase taxes to get additional revenue, well, then they just crank up the printing presses. So that's where all this new money came from. The government printed it and spent it into circulation through all these programs.
And from the looks of it, no one seems to be in a rush to slow things down.
A sweeping nearly $2 trillion relief package to tackle this pandemic, one of the largest in our nation's history.
In fact, no one is really talking about this at all.
And right now, nobody seems to think that this is a problem. People seem to think that we've stumbled on the equivalent of a monetary fountain of youth. People like to call it modern monetary theory, which is we can have whatever we want as long as government prints the money to pay for it. That there's no limit. That government is free as long as they print money. Now,
and strangely enough, we haven't seen much inflation for everyday goods like gas and food. Prices definitely haven't gone up anywhere near 40%, and other countries seem to be following suit. So the question remains, where is the inflation? The reason why we haven't seen inflation yet is because the amount of money being printed is only one of the factors that contributes to inflation. To get inflation, here's everything you need. Number 1, industrial output. How much stuff an economy makes. The more stuff, the more supply, which equals lower prices. The less stuff, the higher the prices. Number 2, employment. Too much employment leads employers fighting over workers, which leads to higher wages, which leads to higher prices. Too little employment leads to employees fighting over jobs, which leads to lower wages, which leads to lower prices. Number 3, the money supply. The main topic of this video and probably the easiest to understand. The more money in an economy equals higher prices, as long as that economy is producing the same amount of stuff or less stuff. And number 4, if the money is exchanging hands, and if so, how fast, also known as the velocity of money. If you print a bunch of money but that money is spent on food instead of gas, food is going to experience inflation, but gas isn't. If you want a more detailed explanation of this, I highly recommend you watch the video by Economics Explained on the subject. It will be linked below. And in our case right now, the money supply has shot up a ridiculous amount, but the other factors have been keeping inflation down. Industrial output, it's been down from businesses not being able to operate, which leads to less stuff. But there's also less demand from you and I to buy those things, so its impact on how much inflation we have is kinda neutral. Employment has also definitely taken a hit, and with less employment comes lower wages, which means lower prices, not inflation. And the velocity of money. It's pretty slow for everyone with all the uncertainty in the air. People don't want to spend money right now if they don't know if they're going to be able to keep their job or find a new one.
And I think the reason for that is a lot of them.
Okay, so column argument. For now, what I want to do is just hard code a column argument and say, let's kind of figure out what that would be. So I think 1, 2, 3, 4, and 5 would probably be good here. So we could just at some point, if we want to pack it really densely, right, and use this kind of formatting, then we can't have any spaces between this at all. Just 1, 2, 3, 4, 5. So we could figure that out. So let's erase all of this for now. And let's say and then right here, we're going to say, you know, return. Actually, okay. So we're going to figure out the column argument right now. It really shouldn't be that hard. It should just be like every other whatever we replace. In some places where we're putting a new line, we just put nothing, right? So if we look for, say, a \n really quick, see if we can find it in the code really quick. No, because we got like \n's everywhere else, huh? So PNG file converted to. Oh, thank you. I've done that before for way too. I'm getting a little bit tired, but I've done that for a whole hour before, and I'm like, yeah, okay, cool, thank you. Okay, so let's look for a PNG file converted to okay. I thought that would be it. Okay, hold up. What the hell? Oh, crap. I'm looking in the wrong code. Oh, God. Have I been editing this the whole time? Oh, God, no. Is this what I've been editing? Okay, no, this is not what I've been editing. I don't know why. Close that. Confusing the hell out of me. Okay, so yeah, so this thing here, is what we want to look at. So this should load file if exists, some blah blah blahs. So uint array to naked text. So this is like the core function that we need right here. And if we look at this, yes, this is what we did a while ago, right? So we got the \n, and we just need to make some counter variable that goes every other for that \n. So we got to figure out where the heck that's been going on. So we got some crazy loop unrolling, and now the time is to see if I actually understand what I wrote. So we got these 10 slots. I'm gonna guess that it's because we have like 10 things in our diagram here. Like, yeah, so we got this 10 thing, and this is 1, 2. Oh, it's just these 10. Okay. And then where's the padding on the side? So where the hell is our comma, right? So somewhere there has to be like a comma and a new line being injected into here. So let's see, we have check inputs, we got variable declarations, variable assignments, allocate string memory, and build text block of array literals. So that would be the code that we want to look at. So we want to look at everything in between here. And 10 characters because 0x ff, so 8 plus 2, 10, yeah, so 10. So these are our 10 characters here, so that's good. So this is the naked text, so it's like, where are we putting the other thing in? So it looks like, okay, here's our comma. Now, where the heck is where's our new line, though? Because I know we have a new line in here somewhere, so let's color this for a second and say, okay, well, there's that. There's one thing solved. But where is our new line? So it was at the other side, right? It was at the other side. Yep, here's our new line right here. Okay, so all we got to do here to get this rolling is we just got to go like some column counter plus plus, and then if, you know, some column counter, we want 5, right? We want 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and on the 5th we want to put a new line. And if we put a new line, we'll do this. And then we'll also set some column counter back to 0. That should be that easy. Should be that easy. We're just going to hard code it for now. And if we ever want to change it up later, we can do that. But for now, we're just going to hard code this. Some column counter. And then we'll put this in the declare variables section. So we should have variable declarations, and we'll have like some int32, some column counter, how about variable assignments? How about some column counter equals 0? Or is that a good idea? I don't know, because I mean, sure, right? And then when we enter in here, some column counter is at 0. 1, 2, 3, 4, 5. We'll see pretty quickly if we have this correct or not. It'll be pretty obvious, I think. Yeah, so let's just give that a shot and just see what that looks like. So first we'll try to compile it and see if we did anything stupid syntactically, which I don't think we did. Okay, and then let's do PNG to naked array, so this thing right here, right? And it kind of looks better, but not, that doesn't look, well, maybe that is. That might actually be right, but it just doesn't look right in the console. Yeah, there we go. So that's done, right? Not that hard at all, right? Now we also want to make sure that we can do the inverse, though, right? That we want to, before we go write a test, let's just make sure that we can do, yeah. Though I still think my code is kind of a clusterfuck. But yeah, let's do the opposite. So naked to PNG, right? And we're gonna take, we're not gonna take that, we're gonna take, PNG or txt.123, right? We're gonna take this and convert it back. Now we click on this, we're gonna see a change. Do you wanna reload it? Yes. Now we see this. Now the question is, if we open that up, is it actually what we think it is? So we're gonna say, we're gonna change this to, well, we're gonna delete this one. And then we're gonna rename this to PNG. Okay, and now we're gonna see if that looks correct. Alright, that worked. Excellent. So we'll just nuke this now. We'll delete this. And now we're gonna go back the other way again. Right? Because we want to get that nice, good stuff. Copy that. And then we'll go find the unit test code section. And we'll just throw that in there, right? So it'll just be like, bam! Get in there. Tab, tab. And tab. Or not tab. So, hey look, we got a little extra space. Why don't we take advantage of that one extra space and just make a little space there. Nice, it's right up against that edge. Excellent. So now we have this logo, and all we really want to do is we want to say so how are we gonna do this? The easiest way to do this is just run the internal functions. So if we take this, not this one, let's take the other one. So the naked array to, oh, hold on. Oh, I need another function. Because this is no longer text, right? This is not text. This is actually a, oh yeah, I actually do need this other feature. So we got this data, but it is it's uint32s. We gotta convert this. You gotta convert this uint32 data to a byte array, because we haven't done that. We've done that in terms of text, right? We've taken text, but now that it's in the source code, it's no longer text. So we need a way to take this and turn it back into a byte array, right? So right now it's a pixel array, you could say. It's a uint32 array. We got to turn it back into a byte array. So here's what I'm going to do. I'm going to do air macro right here. Air to do u32 data convert to byte array. So in order to get these tests running, I'm gonna need bots. I'm gonna need something like that. Well, actually, hold on. I mean, we can just try to invoke the command line. Yeah, why not? So let's go. Let's try to write something at least, even though I might not like it. Yeah, I guess we should kind of test the command line. So I did take, so this is called standalone main, right? This nice, beautiful camel case you hate. Standalone main. And it's just main. The reason I don't just call it main is because then I might confuse it with init, and like in my main code base, I have all these functions that I call init for the different subsystems, and I think that I would I think I would mistake if I called this main, if I called it just main rather than standalone main, I might confuse it for one of my init functions later, right? So I don't want, if I have something like my library init, and then I have my library main, it's like, okay, what is the difference between init and main, right? Like that, I think is going to be like would be very confusing. So I'm calling it standalone main. So the idea is that it's standalone means, hey, when I'm being compiled as a standalone utility, I'm not part of a larger system, I'm not being compiled as part of a larger system, then, hey, you should use this. Or, right, like I want to understand, yeah, it just makes more sense to call this standalone main than main. I don't know if that makes sense for why, but yeah, that's what I've chosen. But yeah, standalone main takes the argument count and the argument array, so we know that. So let's just steal this. Actually, let's kind of reformat this a little bit like that, so I can just copy paste this a little bit easier. And then we'll go back down to the bottom, and we'll just say, are we not indented? Oh, okay. So right here, we're gonna say like standalone, whatever the hell. And actually, if we want this to work, though, we have to save this to file, right? We have to save to file. So let's do... We should have a save function somewhere. Save text file to disk, right? So save txt file. Now I believe I'm using this function kind of improperly. I'm using it for both text and byte arrays right now. Yeah, I'm fairly certain that, yeah, number of bytes, text to save, yeah, file path out, file data out, file data number of bytes. I guarantee that I'm, yeah, see, I even have a note here. It says, this is a bit hackish, saves actual text or PNG binary, right? So I'm using, this thing here. So what we could do, really quick, is we could find this function. Let's find this function for a second. And we're just going to take this function. Yeah, I know what we're going to do. We're going to take this function really quick and to... This is not the best solution, but, we're gonna take this. And we're just gonna say save file PNG. And it's not really going to do anything, right? It's just going to wrap save file txt. And so that way it'll be a little bit easier to refactor this later if we ever try to do things the proper way. Hack file PNG is just a wrapper of Okay. So we're going to make a note here and just say, you know what, this is a hack. We could also do this. We could also note it as a hack like that. Like have it a little bit easier to search for by putting it in square brackets like that. And then 126, and the time is 5 hours and 39 minutes, and let's say 12 seconds. Okay, save file txt, and then right, we have to get rid of so for this, right, name of file, that's good. String to save to disk is not going to be this, it's going to be a UO8 pointer here. Instead of char array, right, we're going to say, you know, UO8 array, and then for string length, we're just going to say, like, I don't know, we could say array length, might make more sense. Or maybe we want to call it PNG length and PNG array. I don't know. Actually, array length makes more sense because then I can see the connection between these two variables a little bit better. And also, I'm not sure if I like UO8 array versus like UO8 array. Have I decided on that? No, it doesn't look like an array UO8. So, to me, this isn't very general to specific. It actually makes more sense for it to be like this. Because, right, they're both arrays. The general identifier is array, and the specific aspect is it's array of UO8, or the specific aspect is it's the length, right? So, I like to have my variable names in a general to specific manner. When we're saving this, what we're going to do here is we're just passing this one on. So that's good. Then char array, char pointer, chr array, and then u32 str len. And then right here, all we're going to do is assign them in here in the call. So like array UO8, and then this is going to be array length. And then this is going to need a cast though, right? So we're going to have to cast this to char pointer before we assign it. So there we go. So this needs a cast. This array length, however, does not need a cast because it's still the same type. And we got these two here. We got these things here. And that's all we should need. That we are thinking that there's going to be some type of output variable. So int32 return a value from function. Return value from function, and then over here we can say, you know, return value from function equals we can do this like this, yeah, like that, yep. Sure, why not? Keep it like in a kind of a Pythonically indented style. I don't really care. But yeah, and then right here, we'll just return this. So return, and then we'll take this return value from function. Okay, so is that all accounted for? Char pointer, UO8 array, whatever, U32, this thing. So then let's put a dashed line here. So dashed line I2x64. So we just have a dashed line that separates these functions. Also, if there's more than one function in a section, I want a dashed line down here so that I can properly identify that there's more than one function in this section. Now, do we want to... Yeah, it's kind of like how I do it. Yeah, okay, that looks good. So, now that we have save file PNG, let's steal this now. And let's go back down to that test code again, right? So, we have... save file PNG. And we want to save... let's call it, unit test UTC dot, we're just going to call it UTC PNG for unit test code PNG. And string to save to disk, right? It's a U08 pointer. So the problem here is that... Oh, crap, yeah. So yeah, in order to get this unit test started, we're going to have to be able to decode this to a byte array. Because right now it's just not in the proper format. The NDNS will be all screwed up. So let's do something like this. Let's say U32 or U08, and we'll say let's call it UTC PNG equals blah 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 U32 U32 array convert to U08 array, and AAC 2020 PHEXDUM and int 32 so let's keep a PNG variable, a length variable, and then this function is going to be void, and this is kind of long, so let's call this, let's just call it U32 array. Right, no need to get fancy. So this is our U32 array right here. And we're going to just say U32 array here. And then we're going to do and U08 array. And then and okay, I keep on changing my mind here. But U08 array and U08 length. So these things here, and put some commas. We really want it aligned, right? So this is the input, and then this is the output. These are both here. So these are the output parameters right here. And we actually need to write this. This is not written yet. So we need to write this. To do. So we need to write the function below here. So I'm just going to put an air macro in here, because I'm going to try to wrap this up and maybe get to bed soon. So after we have this, we have the array of U08 and the array length. So we could make a note of this, that so it's an array of U08, and it's the length of that U08 array. That's fine. And then once this is saved to disk, we can create an argument array here. So we could say char pointer arg array, or arg, yeah, let's call it arg array, and then arg count, right? We could just put that in there like that. So it has to be a constant expression, arg cow, so that this would have to be arg, and we'll just say ignore first so we don't care what the first argument is. We're gonna ignore it because it's user supplied. All these strings, yeah, that's fine. So this first string, and then the next string is going to be we need to take so PNG file converted to naked text, and then we want to use utc.png, right? So this unit test PNG, we want to use it, and we'll define argument count as two arguments. Well, actually, we should really have the output will be the etc txt, right? And then once we have this, let's undef arg count. Once we have this, so char pointer, it needs to be char pointer like that for the argument array, because it's a list. And so we can get rid of these. And then I don't know how we're gonna do this, and I think this is fine. So we need another argument, right? We need another 1, 2, 3. So there's actually 3 arguments here, or actually 1, 2, 3, 4, right? There's 4 arguments here. And we also want arg-array 1, and then this is arg-array 2. Arg-array 1 and arg-array 2, and this is going to be the opposite. So this is going to be naked converted to PNG, and then this is txt, and this is PNG. Alright, so we're going to flip it around. Somewhere in between this error to do delete original Right, so we need to delete utc.png here because we just converted it into a text file and we want to convert it back, right? So right, we're going to call with the arg count and the argument array, and we're going to count with arg array 001, and then we want to delete utc.png here, and then we're going to do this other thing. We're going to load these arguments into here, and this is going to be arg array number 2, same argument count, and then once we have this, we need to load a file into memory. So then we need to we gotta load the file into memory. And then once it's loaded into memory, to convert U08 memory into U32 memory. And then finally, compare so we want to do something like this. So I am kind of just tired, so I'm just gonna commit what I have. Git status, git add dot, git commit dash am, make unit test. So I'm gonna get out of here. Just push that up to GitHub. It is broken code, so it's not pushed up to Kanji Coder yet. Or actually, no, it is pushed up to Kanji Coder because it's a little utility function. But yeah, I'm getting out of here. Because this is going to be a lot of code to write to figure all this out. and so I'm gonna do it at another date when I'm actually not tired, because I am kind of tired. I just wanted to do a little bit of work. So I've actually gotten 6 hours in, and I did 2 hours earlier, so technically I got a full workday in, so that's cool. But yeah, I'm out of here. Good night. Okay. Yeah, I'm out of here. I'll see you around. Yeah, because I just wanted to get a little bit of done. But yeah, got my exercise, got a little code done. That's good enough for me. So later.